Okay, so is this all in Jupyter?
Yes.
Okay, so if I just downloaded all your stuff and I just open it, I get a Jupyter notepad.
I mean, you have to create the environment first.
Oh, I have to create, so
Right,
it's,
so if you just do the setup instructions.
yep,
Then that walks you through. You have a bunch of options like
Okay.
local, Docker, etc. Do you need help?
and I downloaded the zip,
Okay.
and I opened the zip, so what do I do once I have the zip?
So if you go to the instructions, the zip is basically the equivalent of cloning. So continue after where it says clone. So you basically did step 4, and now you need to go from step 5.
Oh, so I already have new conduct, so the new conduct and Python, so I should do UV.
No. So you can pick either one. So if you already have Miniconda and that's what you want to use, then just continue with that. So you just now go to step 6, and you would do the conda, this part, where it says conda env create.
In command line?
Yeah.
Oh,
Yeah. Well, I also, because if I have to stay close to this, that means really like standing in the same spot.
yes.
And standing is worse than walking, so very glad I asked this. I'm also presenting tomorrow,
Yep.
so it's in a different room, but like if we can just earmark the chair.
Okay. I'll let Jim know.
Okay, appreciate it.
Just a reminder, if you could repeat questions that are asked into the microphone.
Okay.
Because it's being recorded.
Yeah.
So that way we can get the questions to you.
Okay.
And I'll probably poke my head in a few minutes once things have gotten started, just in case there's any fires.
Is there someone like running the session or no? Like
No.
Okay.
No,
So
just go to
okay.
yourself.
Cool. Got it.
Me and the other chairs
fires popping in.
For fires.
Okay, hopefully none. Okay, that's good.
So where does Pandas workshop have to be in order to read it?
So wherever you unzip those files, that's where you do it.
Just gotta go with
You have to go into there, yeah.
Instead of CD Pandas workshop, I have to do the whole.
Wherever that directory now is, yeah. It's the advantage of the cloud.
My name is Cameron. I'll be your AV tech for today. Just making sure everything is all good for you and everything is working.
Yeah, someone came in and we did all the testing already.
Yeah, the camera system.
And
So-
this too.
Oh, the podium mic too?
Yeah.
Yeah, because they're doing the recording for
Yeah.
that and the YouTube. Just making sure on that. And is there going to be any audio in
No.
the presentation? All right. If anything, it'll be that little SDI cable.
Yeah, I
and
saw,
those-
I tossed it down because somewhere in there, so I was like, I don't need this.
Oh, okay. So do you have any problems or concerns? My phone number is on the business card, which is right behind on the mixed board. So see that little cart right
Yeah,
there?
yeah. Oh,
My
it's on
business
there.
card is right over there, so any problems, just call us directly and we'll fix it up real quick.
Okay.
Other than that, any other comments, concerns, feedbacks?
The lights are staying on? Yes?
Yeah.
Okay.
If you want.
No, I don't care either. Just to know.
Otherwise, if need be, there is a control panel right there, and that can easily be changed up.
Okay. No, it's fine the way it is. Just to know what's gonna happen. It's not like. Okay.
If that's anything on the camera side of things, generally the lights are this way. Otherwise, if you wanted it darker for your presentation, if it was too bright, then yes, the control systems are right there.
Yeah. Okay.
All right?
Cool. Thank you.
No worries.
I appreciate you coming here. So I had foot surgery 6 months ago. So the more you come here, the better
I
for me.
can come right to you. So what am I doing here? Okay, so this is what I downloaded your zip file
Yeah.
to.
So now, yeah. So you. What is this? Is Windows. Okay, so you're in the directory. So
Yeah.
now you don't do the CD. You do the next line.
Okay, which is the,
So it's in the same block. Scroll up. It's in the scroll up. There's
Okay.
3 blocks, and you want the middle one. This one. This is the condo one.
Yep.
So you copy that condo M.
oh, this right here?
Uh-huh.
Oh, okay,
Well, no, don't copy
No.
the whole thing, right? So you
Okay.
want the first, copy that line,
yep,
just that one, and run that.
copy,
I think you can put it over here if it helps.
okay.
Just lower this.
Sorry to be such a pain.
No worries.
And then I go to.
So now run
to-
that line. Yeah, run it there. I think maybe you need to use Anaconda prompt. That was probably, so let's try that, see if it works.
Looks like it's trying. Okay, is
Yes.
that right?
Yeah, in Conda you have to wait and see.
Oh, yeah, it'll tell me.
Yeah. And then, so when that then finishes running, then you do the second one, Conda activate Pandas workshop. That stays exactly the same because that's the name of the environment, not the folder.
Yeah.
And then the final one, Jupyter Lab. You'll just launch Jupyter.
Oh, and then it opens up a Jupyter Lab
then you'll have
page
all
for
the stuff.
then I can follow you along.
Yeah.
And then I can copy the code into my Spider.
You could if you wanted to.
Okay, that's what I'm gonna eventually do.
Go ahead.
Okay. All right, we'll see if it rolls. It's no criticism of the procedure. It's spot on. Except I've written a million procedures too, and everybody asks me questions, so
Yeah.
we're on the same. Yeah. I'm just trying to learn how to direct someone to do what I want. And so I just need to kind of know some of the things that are going on. And, I've been doing really good stuff in SciPy. I have a very large data frame to analyze. And I'm familiar with numerical methods, which are packages that specifically do specific stuff. And what I'm trying to figure out is whether today's supposedly AI data analysis stuff is smart enough to be like an engineer. I'm not sure if it is. If you never know what package you want to use, you get what you want.
All right, everyone, it's 1:30, so let's get started. So this is just so you have the information for what we're going to go over. If you haven't taken a picture of this slide, I would recommend doing so. Since it's not actually in the slides, you won't have access to this information later. Particularly important is how to access the slides and how to navigate them. I will be using the same set of slides that you will have access to. So this will just give you some hints as far as the hotkeys that you can use to navigate. So I still see some phones, so I'll wait. Okay, that was the last of the phones. So let's get started. Okay, so these are the slides that I said that you would have access to, right? So this, if you haven't opened it up yet, or if you happen to have the repo open, you can also click on the link right here. So in the About section, and that is the link to the slides as well. Okay, so welcome to Introduction to Data Analysis using Pandas. So my name is Stefanie Molin. I'll share a little bit about myself before we dive in. So I'm a software engineer at Bloomberg in New York City. I'm one of the core developers of a tool called NumPyDoc, which is used in a lot of the scientific Python packaging system for documentation and docstring formatting. I'm also the author of this book here, Hands-on Data Analysis with Pandas. It's currently in its second edition in Korean as well as in Chinese. I brought the first edition because this is all I had on me at the moment. I am giving this out for free to anyone who would like it at the end, so just let me know. So I did my bachelor's in operations research at Columbia University, and I did my master's degree in computer science from Georgia Tech. So to follow along with this workshop, hopefully you are all familiar with basic Python and Jupyter, even if you're going to copy things out. It shouldn't be too bad. You can also use Jupyter in things like Visual Studio Code, if that's more your thing. There's a lot of different ways you can work through the notebooks as long as you understand how, kind of what a notebook is, you should be fine. And then aside from that, who does not have their environment set up? Okay. Yeah, well, I'm guessing yours isn't set up either. Okay. Okay, so it sounds like everyone is good. And if you end up having, or realize you have an issue with it later, when we hit the first exercise, just feel free to call me over and I will try to help you troubleshoot what's going on over there. So today we're going to work through 3 different sections of this workshop. We're not going to do the fourth one. So we're going to talk about the basics of working with pandas first, and then we're going to spend the majority of the time working on data wrangling with pandas, because that's where pandas really shines. And then finally we'll wrap up with some basics of data visualization that you can do directly from Pandas. So to get started, I just want to make sure that you all know where to actually work. So notice that there's this slides directory and then there's this notebooks directory. Please only use the notebooks directory. The slides, instead of showing you the exercise to do, will end up giving you the answer, which doesn't really help you learn anything, right? So just make sure you're working in the notebooks directory. Okay, so let's start now with the basics of Pandas. Can I just have a show of hands who's never used Pandas before? Okay, a few people. Who would say you have minimal experience with Pandas? Okay, so that's more expected. Okay. So in this section, we're just going to get familiar with the basic building blocks of Pandas. So what the main classes are, and I have them up here. So series, data frame, index, what they represent, and kind of why they're there. And then we're going to work a little bit with how you can look at pieces of the data, so extract little subsets or do some summary calculations. Overall, like the basic level of how do you get familiar with the data that you have, and that will lay the groundwork for how do we do data wrangling later. So let's talk about what a data frame is first. So a data frame, where you can see on the bottom, so over here, this is a data frame. Now it might look like something maybe you get from a database, right? A table in a database. It might look like a spreadsheet, right? The data frame is another way of representing that kind of a thing. So we have tabular data here. We have, maybe I'll just point here instead of in the pointer for the interest of the recording. So we have columns, right, in a table. And these columns in Pandas world are called series. And then we have also these index. So from 0, 1, 2, 3, 4 is one index. That's the row index. It's a label for the row. And then we also have these across the top, which are another index. This is the index of the columns. So the index holds our labels of things. The series is a column, or could be a row, but like it's a single direction slice of it you can think of. And then the data frame is combining all of that. So the data frame has the index and it has a bunch of series inside of it. And we're not going to cover the code here just yet. We'll come back to that once we understand a little bit more about these pieces. Right, so if I had that data that I just showed and I wanted to turn or extract one of the series from that data frame, one way I could do it is just saying .name. And here now you can see what a series looks like. So we have the values in the series. We have the name. Now here, it's a little annoying because it's name, right? But name was, this one here is the name of the column and it corresponds to this bit right here. And then we have the type object, so the type of data that we're working with here. If anyone's familiar with NumPy, you'll see a lot of similarities start to pop up when you dive into the types here. So like dtype is kind of how you, it's pretty much the same as how you would get to types from NumPy objects. You say, what type is it? What's the dtype? Same thing. Sorry?
Case sensitive?
Yes. Yes. And we'll go into a variety of other cases where like you might not get all your column names lowercase. Your column names might have spaces. Then what do? We'll talk about that later. But if it behaves as a Python variable would, like a name that's allowed to have, then you can do the dot notation, basically. Okay, and then the interesting thing to note here is that we also have an index, right? The series has its own index. The data frame has the index. So here again, 0, 1, 2, 3, 4. And the index is used for calculations under the hood in Pandas. We'll see examples where it's not just the row number later, where you can get a lot of useful information by putting information on the index. So now looking at the columns, now we can see the first of the index that I was saying to you about, right? So if I extract the columns, I now get this index object. And the values of the index are just the names of the columns. So whatever was stored across the columns name. dtype, with the data type again, object. You'll notice that object, for the most part when we're working at things, it means that it's a string, because we're typically working with strings. But if you have more complex data structures, like potentially you have a tuple or a JSON object inside of it, it's just going to say object. And so you have to actually look at the data to see what it is that's inside. And then the index that we would call the index on the data frame is typically the row labels. And here you can see that it's in this case, a range index. This is the default index that we will see. And you can think of this just as a row number. So in this case, it's 0 to 5 by 1. So 0, 1, 2, 3, 4. Okay, so now we're going to talk about how we can actually create a data frame. I do have a link here, so if you want to look at this later on the page in the docs, where they basically list every single possible way that you could make a data frame using functions that they provide. We're obviously not going to go through all over that. We're going to just focus on read CSV. This is quite a workhorse in the sense that it's not just for reading CSVs. It can also read like tab separated or other kinds of separators as well. So that is usually where you would start if you're working with any kind of flat file. So what we do first is we have to import Pandas in order to be able to access the functionality that the library provides. And we would typically alias it as PD. Is there anyone not familiar with import aliases in Python? Okay, cool, everyone understands. Okay, so once we've imported as PD, we don't say Pandas anywhere else, we just use PD. And then we're going to use the read CSV function. And at its most basic, all you need to do is provide the path to the CSV file that you want to read. So here I'm passing from the data directory that you all have in the repo. There's a file there called meteorite landings. And I'm just passing the path to that. And then Pandas will read it in, turn it into a data frame, and then return the data frame back, which I store as meteorites. And that was the data that we saw before, with the exception that I only read in 5 rows. There's way more way more meteorites in that data set, and we will be working with them throughout this section as well. So just to get a taste for another way you might do this, we can actually grab the same information from one of NASA's APIs using the requests library. And so if you make the request to the particular endpoint that they tell you has this data, then you could get back a JSON response. Okay, so you can think of that as a dictionary, or it could be a list of dictionaries. So where each dictionary would be a row, and then you have a list of rows, and then that can be used to form your data frame. So with that data, instead of doing read CSV, because you're not reading a file, you would then pass in your Python data structure into pd.dataframe. And then Pandas will create the data frame out of that data that you're passing in. So here, I'm calling this df just so we don't overwrite meteorites, which we had before. And if we just look at the first 3, which is what I'm doing here, you can see that the data looks a little different than it did before. Can anyone point out something that is different from this data set? I said it's the same data, right? So it's both meteorite landings, but for some reason, there are differences between how the API is returning these values and how it's representing them, and what was present in the CSV. So take a look at this. Does anyone see anything that's different? I'm going to go back. So here's the CSV. Okay, the date format is different. That's one of them. That wasn't one of the ones I was thinking, but it could, yeah. I think you're close to something when you say that there are any ands in it, right? It's particular if you look at why those are there, right? So if we look at the data, these are new columns, right? So they weren't there in the other data set. Geolocation, yes, that's the other one. All right, so here, this is an example of what I was saying. You can actually have JSON, or a dictionary, inside of the column, and this would be another column that would show up as being an object data type, but that's definitely not a string, right? So yeah, those are all differences. And then if you look at the year one in particular, the year format here is much better than the other one, because the other one is ambiguous, right? Because we don't know if they were day, month, year, or month, day, year. At least not with looking at those first 5 records that I showed. They were all 0101, right? So these, because of the way it's returning a JSON response, they decided to treat these as date times and return them in a specific way. So little things like that sometimes are helpful to take advantage of, because it might be that the file or the data that you're trying to consume is kind of messy from the flat file, but is much easier to work with from the API, right? So you can use that to your advantage rather than wasting time doing extra data wrangling when you don't need to. So it's a good thing to keep in mind. Yeah, and then if you do something like this, you would probably then want to save your data, right? So that's just a quick way that you can save. So if you have your data frame object, it has a toCSV method, and then you just provide the path to where you want to save it. So you could do the full workflow in reverse that way. Okay, so let's look at how we can inspect the data that we're working with. We're going to work with the media rights CSV. So I mentioned that instead of just reading in the first 5, this time we read in the entire file. So if we access the shape attribute, and again, this will be like what you would see with NumPy. We get a tuple back. So we get that there are 45,716 media rights. So that's the number of rows. And that we have 10 columns of information on each of those media rights. Right, and then usually when if you start going through this way, we already know what the columns are because we looked before. But if you had just read it in, you might first look at the shape to see what it is, and then you see that there's 10 columns. Your next question is, what are those 10 columns? And so again, you can access the columns attribute, and then you get back the list of, or the index containing the columns. This doesn't mean you know what the columns actually are holding either, right? You would want to see if there's some sort of data dictionary provided that explains what each of those fields mean. The next thing, right, you might want to see now what are the data types of those particular columns. So when we extracted the series and the index, we saw there was a D type. The data frame, we're not restricted like an array to having one type for everything. So you can have multiple types. So when we want to see the types, we say .dtypes plural. We want to see the data types for all of the columns. And so now we get back, does anyone want to say what data structure this is? Yes, correct, it's a series. So this is a series, and now you see it's different, right? So now the index of this series is over here. So name, ID, name type. So the column names are now the index, and then the values in the series are the data type for each of those. So name is an object, the ID is an integer, the mass is a float, etc.
So that series is not saved.
So the question was, that series was not saved?
Correct, so you can't, unless you,
Oh, yeah. So if you wanted to work with this again, you need to assign this to a variable. Okay, and then at this point, right, you now know a little bit about the data, and to actually see the data, the best way is not just to print the whole thing, right? We saw 45,716. It won't print all of it, it'll just put ... but it's a little more, it's better practice to just print actually, like, I just want a few rows. So if you call the head method, you'll just see the first 5 by default, and you can pass in a number. Maybe you want the first 10, you can pass that number, but you're not accessing all the rows and then having it truncated. And again, now we see our data. The other thing that is important to do when you first get your data, right, is so we saw the D types. Sometimes you look at this, right, and then there might be a column that surprises you. Like just looking at the names of the columns, for example, seeing the column called year, personally I would think, oh, that should be an integer. I would imagine year would just be the year. And so you might want to confirm there's nothing strange going on by using head, yes, but also by using tail. Because sometimes, for example, they might put the data dictionary in the file at the bottom below the data, right? And then when Pandas reads it in, depending on how that separation between that last row and the description of everything is, Pandas will read it in, and by the end of that, the last row, it'll say, oh, there's text in here. So everything's a string. Done. Right? So check this last bit. So check the tail to make sure that there's nothing strange in there. Here, this looks just like what we saw with head, right? So, different values, but the same type of structure. So we know we're okay here. But that's always a very, very good sanity check, just to make sure there's not something strange going on.
So if I created CSV from Excel, I know it. Should I check this? When Excel creates a CSV,
Yeah.
is it going to put stuff in there that I should check, or should I?
So the question is more about Excel, so I really can't answer. But the question was, if you use Excel to convert to a CSV, is it putting anything there? It would really depend on how you're doing it. If you're careful to only select the part that's not describing anything, it's probably okay. But I don't know, it doesn't really cost too much to double check that there's nothing there. It saves you the headache later, for sure. Okay. So another way of getting some information, right, we can use the info method. And here we have a lot of different things, data points some that we were looking at already and some that we haven't touched upon yet. So we can see, for example, we have the number of meteorites right here. So we have 45,716 entries. We see that we have 10 columns. We have the names of each of these columns. We have their data types over here. What's very interesting about this method is you get the non-null count. So, for example, here we can see that there are a lot of meteorites comparatively to these other columns, right? Like this one is never null. But this one down here, these three, the geolocations, there's a significant amount of nulls, right? So they don't have the location for the meteorites. Does anyone want to guess why that might be? Why would there be no location for a meteorite? Somebody brought it to someone. It could be. It could be like a story, or there was, in a history book that everything was dark that day. There was this big crash, or it could be that at some point people in ancient times found it, they moved it, and now we know that it fell on a certain date, but they don't know exactly where, and they're not just going to put any information there. So there could be a lot of reasons. Right, but it's interesting, it's important to go into the analysis with these types of things in mind, knowing that that column, or those particular columns, have some empty values in it. And you could also try to check, is that actually related to something? Is it that only ones that were just found somewhere on Earth versus obscene falling that we don't have the location for? So you could dig into that as well. The last interesting thing I'll point out down here is that it also tells you the memory usage for this data frame. This is not going to correspond to how much memory that file uses on disk, right? Because when Pandas is reading it in, there's a lot of extra stuff happening, the overhead of creating all those objects, so that memory usage will be much higher than the file itself. And as you start working with bigger and bigger things, you do have to be mindful of that growing too much. Okay, so with that, we're going to dive into our first set of exercises. So we will do 5 minutes for these. And if you're stuck on anything, just raise your hand and I'll come over and help you.
Once I have this screen up like this, what do I do?
So you can go into the notebooks directory.
Pardon?
Notebooks, click notebooks on the right, on the left, sorry. In the file browser on the left, click notebooks. And then click the first one, notebook 1, where it says 1 dash. Yeah. All right, was everyone able to get those two exercises? Does anyone need more time? No? Okay, cool. So let's go over them. So for the first one, we're reading in a different CSV. So we were working with meteorites, and in this exercise, we're going to work with yellow taxicab data. So to read it in, we import pandas as PD, and then we use the read CSV function, right? And then we pass in the path to the new CSV that we're going to be working with. And we're storing the result as taxis. So taxis is the data frame for this data. And to see the first 5 rows, we can simply call the head method, and that will automatically return those first 5. So here are those first 5 rows. And then to see the dimensions, so the number of rows and the number of columns in the data, we can use the shape attribute. So taxis.shape returns the tuple, and we see here that we have 10,000. So this is a 10,000 row sample out of a much larger data set. And the data set has 18 columns. And we'll work with this again later as well. Does anyone have any issues with those exercises? Cool. All right, so now we're going to work on how we can extract subsets from the data. So looking at particular ranges of rows, for example, certain columns, things where certain conditions are true. So we saw already how we can access a series like this using the dot notation, and we had the question before of does this work if it's if it was case insensitive, and there's a variety of ways where this won't work, right? So for something that is a valid Python like variable name, like name, this works. It's not reserved for anything else. It won't clash. Like something like the word class will cause problems, right? Because that's a reserved word in Python. Something with spaces, special characters, etc. There's nothing that stops you from having those in your column names. You just have to change how you work with them. So one of the ways around that, and this also is more, there's more things you can do with it. So for example, if I wanted to select 2 columns, I can pass in a list. So that's this inner part here. So oops, let me grab the brackets. So the highlighted part is a list of the column names that I want, and I'm passing it to meteorites square brackets. So just like you would key into a dictionary and you would put the key, here we can put multiple keys as a list. And so mass, like we would never have been able to select that doing it this way, right? Because the second you put mass space, and now you have an error, because first of all, it's not going to find mass. It doesn't exist. And then you have these weird parentheses, and that's going to cause problems. So you can just pass in like this. So if you only wanted mass, you remove this part, and you just pass the string mass into the single set of square brackets. What's also nice about this is you can actually use it to rearrange the columns. So here I said name first and then mass, but if I say mass first and then name, the columns will return to me in that order as well. So it will be mass on the left. So to select rows, one thing we could use is slicing. You do have to be very careful with this. So here I'm saying from 100 to 104, slicing in Python is exclusive of the end index, and so we have no row 104 showing up here. The reason I said you have to be very careful with this is right now these index values are the row number. So row with the index of 103 is actually index 103, but that is not always the case, right? If I have some different value in there, if I sorted the data, right, then that won't be the true anymore. And so these are the ones at those positions, not at those labels. So you have to be careful with that. The better way to do that kind of selection is by using indexing in Pandas. So there are 2 ways to do this. One is ilock, and I like to think of the I meaning integer, right? So you see that all the values I'm putting in here are all integers. So I say meteorites.ilock, and then I have square brackets, just like we saw on the previous slides. And then I say, give me the rows that are 100 to 104. Again, exclusive, there's no 104 here. But now I'm saying that I want columns at position 0, 3, 4, and 6. and here you can see the columns come back. So that's the annoying part about iloc, is you need the integer, right? But sometimes that is the way you have to do it. So the other way is to do it with lock. So notice there's no I now. So these are now with the labels. So you can think iloc for I for integer, and then lock, L for label. Okay? So when we do lock here, it's again 100 to 104, pulls things out. But notice something different happened, right? We actually now have 104, right? So this is not the same type of operation, okay? So here, this is a range of the names on the index, not their positions, okay? So it would be very hard, especially like when you look at something like this, for example. So here I'm saying to Pandas, get me everything from the mass column to the year column, including both mass and year. Here, there's only one column in the middle, and that's fall, but you could potentially have had 10, 20 columns in the middle. It would select them all, right? So how would slicing be defined? How awkward would it be if you, instead of saying the last column that you wanted, you had to say the one after the last column that you wanted, right? That would be extremely cumbersome and very hard to keep track of. And so that's why the behavior on this particular one is different, is because these are labels. Pandas has no idea that they're just the positions in there. It says, no, I'm getting the ones that are labeled 100 to 104. So starting at 100 to 104 and everything in between, okay? So L for label, I for integer. Okay, so now we're going to talk about Boolean masks. So I guess I should have asked before, who's familiar with NumPy? Okay, so you've probably done masks at some point, right? So same kind of thing. This is something that we will be able to perform an operation over a vectorized input. So for example, over an entire column, over an entire row, and maybe you want to check, is the temperature greater than 20 degrees for every single recording of temperature, for example. So that gives us a Boolean mask. So that's the same size of the data, but instead of the actual values of the data, we just have true, false values for each of those. And then what we can do is tell Pandas to filter the data down, only giving us the ones where it was true, for example. So here's what a Boolean mask would look like. So here's a mask that tells us which rows, which each row is a meteorite, so which meteorites weighed more than 50 grams and were found versus observed falling. So let's break this down a little bit. All right, so here's, again, what we were talking about. How do you select a column that has spaces and stuff in it, right? So we have to use the square brackets. So this particular piece here extracts the mass series from the data frame. And then we compare it to 50, the number 50. So for each record in that series, we say true if it was greater than 50 grams or false otherwise. So this particular piece here results in a series of length 45,716 of Boolean values, which will look like the bit on the bottom, but that's, we're using 2, so it has to be a little bit more. So for example, this one, because of the Boolean logic, we know that for the 50 gram check, this one up here, that this meteorite 45,711, was more than 50 grams. The second condition is we're just checking in the fall column if it is equal to the string found. So we'll see again later how we could see which unique values are in the column, but I'm telling you ahead of time there are 2 unique values in this column. Found, if someone stumbled upon a giant rock, oh, that's a meteorite, basically. Or fell, if someone's, oh, what is that falling from the sky, and then they go and retrieve it. That's the 2 differences, right? So these are all the meteorites that were found and weighed more than 50 grams. So how do you combine 2 series, right? This is a type of thing that is a common error in Pandas. You will see something referencing like can't compare like many values, because like you normally in Python you would say, X and Y to evaluate your 2 conditions, like the actual word and you cannot do that here, okay? That's why we have the bitwise AND operator. And this makes sure that the comparisons are done element-wise. Okay, so basically you take the two series and you line them up by their index. And that's again where the index comes into play. So pandas will say, okay, at index 0, what does this series say? And then and that with what this series says at 0. And then that goes all the way down for those 45,716. Okay?
Why
Yes.
is it dot fall instead of bracket?
The question was, why is it dot fall instead of bracket? It's less typing, right? It works that way. Personally, yeah. I do it with, I mean, it's personal preference. Some people prefer to always do the brackets. I just like to minimize the amount of excess keystrokes that I have to make.
Because mass has a space.
Mass has a space, yep, and the brackets, right, and the parentheses, so it makes things more challenging. But we're going to see later how you can rename that column and stop having to type all of that. Okay. So with that Boolean mask, we can then filter the data down. So here I've changed the mask a little bit so we have fewer results coming back. So here we're using the same mask, we're still using a mass check, but this time we're checking if it's more than 1,000 kilograms and whether it fell versus being observed, or sorry, if it was observed falling versus being found on Earth. So we take, this is the entire mask, that bit, right here, okay? And we just pop that into the square brackets for meteorites. And we get back 5 records. So these are the only 5 records, 5 meteorites that meet that criteria. And we can confirm this, right? If we look at the fall column, we see that they all have fell, which was the first part of that criteria. And then for the mass, these are all greater than 1,000 kilograms. Any questions on the mask? No.
Sorry.
Yes. So if I don't put meteorites in brackets, I just get this, something like this back.
Oh, okay, okay.
So this is, this,
That
yeah.
is the math, sorry.
Yeah.
You're just trying to get the data back.
Yeah. So now, I mean, realistically, you're calculating the mass to use it to filter data at some point, right? So in order to actually filter the data, then you have to pass the mask into the selection, right? And that's what we have the squares here. You know, I mean, this style of doing it has a lot of parentheses and bitwise, and it's very tedious to type all of this out, right? So I'm going to show you another way of doing this, but just really quick, we saw lock and iLock before, right? So we had, for these things right here, you can also put in, like, maybe you want here some Boolean mask that tells you whether or not to select the column or not. And so you're calculating this on the fly, not saying, oh, what position was the mask column? Oh, it's at position 4. Like, you can move away from doing all that. So combining Boolean masks here, instead of specifically saying you want certain numbers, is much more useful.
I got a quick question.
Yes.
So for meteorites, inside that square bracket, I could put in, if I made a series of 45,000 or whatever, true, false, like the first are all true, the first 10 are true, everything else is false, that would just print out, that would be like a head. Right?
Okay.
So give me the first.
Yeah, so the question is if we made a different Boolean mask that was just something standard that was just first 10 were true and then everything else was false, and we made sure to keep it the same size as the data, would that be the same result as head 10? And yes, it would be.
So that really is just, you could put in a mask that you generate some other way.
You can generate it any way you want. You just have to make sure the size is correct, right? So here, we're selecting, we gave it a mask that was the length of the rows to filter the rows, right? But you can give it one that is to filter the columns, and in that case, it has to be size 10, I think we're working with here, right? So as long as those dimensions match up, you can filter. Now, if you give it 1 less or 10 less, it's not going to work. You're going to get an error because it doesn't understand what to do with those pieces. Okay, so here's the less cumbersome way that I was hinting at earlier. So instead of all the brackets and parentheses, you can use the query method. So here we pass in a string, okay? And this is a syntax that Pandas is interpreting and converting it basically into the other logic, right? So we then have the same problem here with mass being annoying to work with. So for example, if we want to just say if something had a value of fell for the fall column, we just say fall equal fell. We don't have to say meteorites.fall anymore because we're querying the data frame, so Pandas already knows we're querying meteorites, right? So that can be removed. A nice thing here, we can now use and again. You can use and, or you can use the ampersand. You can use either one, so whatever one you like here. Both will work. Pandas will do it correctly. The trick here is how do you actually put in mass, right? Because if this is being interpreted and there's a space, again, you have the same problem like you would if you did meteorites.mass space open parenthesis g. And so for anything that you couldn't do the dot notation to select that column, you can surround it in backticks. So again, reserved Python words, things that maybe actually correspond to a method on a data frame, etc. You can just put it in these backticks, and then Pandas will know that this particular piece of the string here refers to a column that you should be interacting on. Okay, so the backticks, mass, and then on the G, this is the same exact result that we had on this slide, right? So much less typing on this and a lot easier to read. So query is a very, very nice thing to have up your sleeve. Okay, so let's take a look now at how we can calculate summary statistics. Okay, so this is what I was saying to you before about how do you figure out which values of that fall column are there. Obviously, you could look at a data dictionary, or you could call value counts on that series. And what Pandas is going to do when you call value counts is going to find each of the distinct values and then count how many of those occurred in the data. So here we see that we have found, so 44,609 of the meteorites were found versus 1,107 that were observed falling. So it's either or for that column. So we can also call value counts on the data frame itself. And here we would pass in a subset. So if we don't want value counts on everything, for example, we just want to look at certain columns. So here, name type and fall. So maybe, so there's one value in here in the name type where it's relict. And if you look at the definitions they have on the website where you can find this data, it's something that they found, basically, in most cases. But they're not 100% sure it was a meteorite. And I guess this probably was a meteorite at one point, right? And so what the interesting thing about doing value counts here is that you can then see, well, if given that description, like how could you not be sure, right, if you saw it falling, for example, right? That's probably a very good indicator. If you see something falling out, then that's probably, okay, that's definitely what we found there was a meteorite. But it is interesting that, in this case, that is true, right? So the ones that are the ones that we probably was a meteorite, right? Those were all found. So that aligns with that hypothesis of how does one get this value. But this does account for a very small percentage of the data. And that's the other bit here to get from this example. So whereas here we got raw counts, right? Here we passed in normalize equals true. And now this is giving us the percentage of the data. So we can see that almost 97.5% of all the meteorites are in the valid name type, so they're definitely meteorites, basically is what it's saying, and they were found versus observed falling. Okay, so aside from counts, if we now look at numerical columns like the mass column, we can do things like extracting their mean, just calling the method mean. This one is very misleading, right? So the mean here tells us that, and I'm going to use air quotes here, that the average meteorite is 13,278 grams, okay? And spoiler alert, that is very much not the average meteorite because there is a large skew to this distribution, right? So let's take a look at some quantiles here. So if we want to look at percentiles, we use the quantile method. And you can pass in a list of whichever ones you want to get. And so here, this is the first percentile, 5th percentile, 50th percentile, or the median, 95th percentile, 99th percentile, okay? And we get all of these back, so the percentile is the index label, and then the actual value of that point of the distribution. Okay, so now this is a very different story, right? So our now average meteorite using the median is only 32.6 grams, right? So compare that to 13,278, right? So a lot of right skew on this data. And again, just also looking at the skew here, if you look now 95th percentile, 4,000, 99th percentile jumps all the way up to 50,600 grams. And remember the ones that we were looking at before, there were at least 5 that weighed over 1,000 kilograms, right? So now the question is, before I jump ahead, so again, median is the 50th percentile. You don't have to do the quantile to get the median, you can just call median. But yeah, so now you see something like this, and now you're like, okay, well, what is the maximum, right? So even just going here, just calling max, is now, again, another order of magnitude larger than the 99th percentile. So a massive amount of skew on that. And then when you think about it, right, how many of them were found versus observed falling, right? If the average meteorite is 32.6 grams, right, it's going to be very hard to see tiny, tiny things falling through the sky, right? So it makes sense that most of them are found. Someone was digging somewhere, oh, what's this little thing? This is not, of Earth or whatever, right? And so that kind of thing now makes sense when you look at this distribution. Okay, so let's just see how we would extract this particular meteorite. So one thing you could do here is we can say, instead of calling max like we had here, which gives us the value of the max, we can say IDX max, which gives us the index where the maximum value occurs. It is not going to be honoring ties, so it's just going to get the first one, I believe. If you do need the exact value, then you could then filter wherever the value is of mass is equal to the max. But if you don't need that, then this is an easier way of writing this. Right? So this gives us the index label where the max occurred. So if we had used meteorite IDs instead of row numbers, this would still work, right? And that's why we use lock, right? Because we're passing in the label where the max occurs and not the position where the max occurs. So the largest meteorite is called Hoba, and you can see that it was found. So now you also can start understanding the data a little better, right? When you see that something this massive wasn't observed falling, right? So this now tells you this was probably old, and then maybe this year isn't fully correct either, right? Now you maybe are wondering, well, this maybe was when they started entering into the system. Who knows, right? So you might have questions about that. But this is actually a meteorite, and this is the one in particular. It's in Namibia, and it's actually a tourist attraction. Has anyone been to Namibia? No? I feel like if I ever go, I will have to visit this one. Okay, so some other things we can do on categorical data. So I talked about value counts, right? And you do have to be a little careful with calling value counts if you have tons of unique values, right? So one thing you might want to do first is just see, well, how many do you have? And so we can take our categorical column here, rec class, and we have the nUnique method, which tells us the number of unique values that are there. So there are 466 different meteorite classes in this case. And then you might want to see what some of those are. So if you just drop the n from nUnique and you now just have unique, this will now pull out all the unique values. Again, we don't want to print 466 values to the screen, so I'm just slicing the first 14 of them out. You can see these examples. Now, I personally don't study meteorites, so I couldn't tell you what all these things mean, but then you could do more research, right? And there's an article that talks about it if you're interested. Okay, so we've been working with summary statistics on individual columns at a time, right? And there's a very, very handy method, the describe method, that lets you get a bird's eye view of the data and get a lot of those summary statistics all at once for all of your columns. So here, I'm giving it something that is not the default. So I'm saying include all. So this is a special string here, that all. That means show all the columns. Because what happens is if you don't have this, and you have numerical and categorical data, you're only going to get the summaries of your numeric data. Okay? So because, and we'll go through what we get back here, but because certain statistics only apply to numerical data and others only apply to categorical data, that distinction is made. So here, just to show everything all at once, we're going to pass in include equals all, and we get this result back here. So this is still a data frame, right? We have the index of our columns up here, but our index, our row index, is now the name of the summary statistic that was calculated. Okay, so count, that's the number of non-null values that it looked at, right? We saw before that the location ones had several missing, right? So that's why these are lower than, for example, this one. We can see the number of unique values for the name. We expect that each meteorite has its own name, although that would not be a good system if it didn't, right? But why aren't there unique values for the ID? Does anyone want to guess? They certainly should all have unique IDs. Okay, so the unique statistic here is considered a categorical statistic. The ID is a numerical column because it's a number. We haven't changed it to category. And so if you look down here, you'll see that for the ID column, we have a bunch of nonsense statistics. We have the mean ID, which means nothing, right? The standard deviation of the ID, again, not really helpful, right? And so that would also be something where, yeah, it's technically an integer, the ID, but that's not the right data type for it, right? Because this is useless to us. We would much rather be sure that we have all unique IDs, right? So moving on, if we now look at, for example, the rec class that we were looking at before, we can see number of unique corresponds to this unique. So we have 466. That was the result we saw before. So we know that's correct. Top. So this is, again, categorical only, and this tells us the mode. So that which one of those categories occurs the most often. So that one's L6. The next one, for frequency, tells us how many times that top value was observed in the data. So this combined with this. So we know that L6 was present for 8,285 of the meteorites, right? And then the rest are NANs, right? Because what is the mean of a categorical variable, right? These are not defined, so these are not a number. If we look at mass, we have the number of non-nulls. We have nothing for unique, top, or freak, right? Because those are all categorical only. So there's going to be nothing there. And on the flip side, now we have the mean, the standard deviation, the minimum, etc., all the way down. Okay? So when you add this include equals all, you then are going to get more of those NANs because these statistics don't apply to all the columns, but you can still at least see everything. And that can be helpful. If we look at the year column, does anything seem weird? No, so this isn't the data, remember, these are the summary statistics, so they will be different, right? So here, we're always going to have a number. This is going to be, in this case, a category, so we're going to have the number of times the category occurs, that's going to be a number. This is going to be the same type as the data itself, because this is saying which record was the most popular. And this is the amount of times the most common one occurred. There are missing, yeah, but that's not what I'm interested in getting at here.
Whole bunch of meteorites fell on January 1st.
Exactly, yeah. So it's kind of peculiar that 3,323 of them were either found or observed falling all on January 1st, 2003 at midnight. Wow, right? So now you might think, okay, is there something special about that date? Does that mean that, or we only put 2003 and then the month and the year actually mean nothing, right? Maybe it's just like in Excel. You put 2003, and Excel's like, oh, this is a date. Okay, 0101, right? Midnight, right? Seeing this number is like a huge, huge red flag. Something weird is going on. So very, very good, right? And so that's what's nice also about this type of view. Now, let's look at that geolocation. Does anyone see something strange there?
The unique should be the same as the commons.
No, it doesn't have to be. It could potentially fall in the same spot.
6,000 fell in the same spot.
Yeah, that's the weird part. 6,214 of them fell at the exact same spot, but it's even weirder the spot that they fell at, 00, right? 00. Sorry?
You didn't want to build a house.
No. Right? So now again, now we're wondering, oh, is 00 a placeholder? And that, depending on who's entering the data, it's 00 if it's not there, or it's empty, right? So that's another thing that you have to see, right? So seeing these top values in the frequency is very informative, depending on the data. A data set like this, where we do not expect to see this many things co-occurring, like on the year or on the location, this tells us that those columns there's probably a lot of stuff that's unreliable in there, and we would have to look at it, right? And we will see later that the year column has extra things going on with it that are wrong. We can't see it yet in this view because it's currently being treated as a category, but we will see later. But this is also a point where you might see, like, what would happen if the minimum here was negative, right? Then you might be like, oh, a negative mass meteorite. Okay, that's a little strange too, right? So you can see a lot of data integrity issues at once just by using this view versus going column by column, right? So this is a very, very powerful method, and it will be part of your toolbox. You read it in, you see what kind of shape, columns and rows you have, what the data looks like, and then go get your summary statistics. That's a good entry workflow as you start working at it. Okay, and I have linked here if you're interested in bookmarking for later, but these are just where they list out on the docs all of the methods that they have for getting descriptive statistics on series and data frame. Things like kurtosis are even in there, and you don't have to define things like that yourself. Okay, so let's do another set of exercises here to practice this. And again, call me over if you need any help. Oops. There we go. How are we doing on those? Does anyone need more time? No, okay. So let's go over them. Okay, so for the first one, we're using the taxi dataset again, and this time we want to calculate summary statistics, but only for 4 particular columns. Okay, so there's a variety of ways that you could do this. So first, we again start off by importing pandas, right? We use our read CSV function, and we pass in the path to the taxi data. This is what we had from the previous exercise. This gives us our taxis dataset. Okay, and the way I'm going to do this is I'm going to take taxis and first only select the columns that I care about, and then call the describe method.
Just to make sure I understand what's going on with it, goes back to the masking. So the reason that there are 2 left brackets after taxis is because that first one that is a list.
Yeah.
And that's,
Yes.
that's really a mask.
It's not.
You're passing into taxis.
No, so this is not a mask, right? Because it's a different. This is a different thing. I'll kind of just rephrase, I guess, the summary of what to get out of that. Okay, so you can think of this as, imagine I had some variable called columns I care about, and that was just a list of whichever columns I actually care about. In this case, it's 4 columns. Okay, the original data set had, I think, 18 columns. So it's already not a mask because it's a different size, okay? And then the only reason there are 2 brackets is because the inner brackets is saying that this is a list, okay? So if I had this variable, columns I care about, then I just say taxis, open bracket, columns I care about. Then there's only one set of brackets, okay? So the inner part, the part that's highlighted right now, is just a Python list. Okay, so to the square brackets, you can pass in a single value. This is 1 column you want. You can pass in a list of columns. These are all the columns I want. You can pass in a mask that is the exact size of the rows, and then you will get the rows back.
Okay, so that's not a mask.
It's not a
It
mask.
just happens to be something else that can be accepted inside a square bracket.
Yes, square brackets do a lot of things.
Okay.
Yeah. Okay, so again, so this is what I was saying is I first select the columns I care about. So this gives you back a data frame of 10,000 records with just those 4 columns. And then I call describe, right? You can see that I was 10,000, right? So this is where that's coming from. The other way you could do this is you could call describe and then select the columns. So you just flip the order, taxis.describe, and then the double square brackets and everything. This is going to be a little bit more efficient, right? Because you're not calculating the summary statistics on everything and then throwing away what you don't want. Here you're saying, I only want these, give me the summary statistics. But they will both work.
Question about the describe method. When would you really need to use the include argument?
So the include argument is if let's say one of the columns I picked here was categorical, it wouldn't show up in here right now. And so if I said to describe 5 columns, 4 are numeric, 1's categorical, the only way you could get that in one piece of code would be to say include equals all. Yeah. Include also does a lot of things. You can also, let's say you have like 30 different columns, and maybe you only want to describe columns that are of certain types. So not just saying all and not just all numerical, maybe you only care about dates. You can say summarize all the ones that are dates. And you can do stuff like that. So there's a lot more uses for that. And that's also kind of why I wanted to share that particular thing, because it does come in handy quite a bit. Okay, and then for the 4th exercise of the second one on the set, we were taking those same 4 columns, and this time we wanted to find the trip that was the longest and extract those particular columns. Okay, so here we are using lock to select things. And so it's because we're using lock, we need labels, right? So we can't use numbers here. So to get the label, the row label for the trip that was the longest, we can take the trip distance and use IDX max. So this is the index where the maximum trip distance occurred, okay? And that is this number down here. So index 8338 was the longest trip, okay? So, and here's also, we touched a little bit upon this, but remember lock has 2 pieces that you can put with the comma separated here. So this part is the row selection, right? So we wanted the row where the max occurred. So that was, it says select row label 8338. And that's this piece. And then the column selection, we want these 4 columns. So again, you can now see like the square brackets aren't right next to each other, but again, like the square brackets can take a lot of different things depending on the logic Pandas is doing under the hood. So the particular trip, right, we didn't include the actual trip distance, but we could have just added that into here. But we can see the payment amounts for this particular trip. Any questions on this one? No. Okay. Okay, so we're done with the basics now. And now we're going to move on to data wrangling with Pandas. Okay? Particularly, we're going to start with how we can clean up the data. And now, for this section, we're going to start working with the taxis data, and we will come back to the meteorites on the exercises. Okay, so here was basically your exercise 1, where we're reading in the taxis data set. So we're working with this now. And we talked about before how there's 18 columns in here, right? And if you look through, there's a lot of things that without a data dictionary, again, we don't know what they mean. Payment type of 1, not sure. DO location, or maybe drop-off location ID, pickup location ID. Not really sure what these mean, right? So for us to just play around with this, we can drop several columns that we don't care about to make this a little easier to work with. And so we're going to do that. And here's another use for a mask, okay? So if we want to drop columns, we can create a mask that is telling us which columns we want to keep. So it's true if we want to keep the column, or false if we want to get rid of it, or we can do the reverse, right? So here we're making a mask. We take the columns, okay? This was an index. So on that index, we can access str, which is where Pandas stores the string methods for data in the index on. And then so we want to see wherever the string contains some regular expression. So we're saying regex true. And what this regular expression is checking if the column ends in ID, so that's this piece here, or, that's the pipe, it has store and forward flag in it. And we know this is okay because we already looked at the labels, that this won't actually be an issue, but it's possible you have a word, I don't know, like braid, where it ends in ID, and maybe you wouldn't want to get rid of that. So you'd have to be careful with your regular expression. So this is, again, a mask, right? We have 18 columns, so there's 18 true-false values in this. And then to extract the columns we want to get rid of, we can use the mask to select the columns, okay? So taxis.columns, passing in the mask, where it was true if we wanted to get rid of it and false otherwise, gives us an index, which you can see down here being printed, of all the columns we want to get rid of. So these are all the columns where that regular expression matched. Vendor ID, rate code ID, etc. So instead of having to enumerate and go through all of them one by one, you can use regular expressions to calculate which columns we actually want to drop. Okay? And then with that, we can use the drop method, and we can simply pass in the columns that we want to drop. Okay? And then if I look at taxis.head, you see that there are fewer columns and we don't have those particular ones. Now, because it is a mask, right, we can also do something a little different. So I have down here, if you wanted to use lock, for example, you can put a special character colon as the row selector, and this tells that you want all the rows. So you're not filtering anything on the rows. And then on the column side, we have the tilde to negate the mask. So now everywhere that was true is false, and everywhere that was false is true. Okay? So this, instead of dropping the columns we don't want, this selects only the columns we do want. Okay? So 2 different ways of doing it. And in either case, you have to assign the result back into taxis for that change to take effect. Okay. Next thing we want to do is rename the columns. Okay, there's, for example, a lot of typing if we're looking at pickup and drop-off times, right? So they have tpep pickup date time, right, where we can just say, let's just call that pickup so we don't have to type so much. And we can do, just like we had the drop method, there's a rename method. And one of the ways, and we'll see other ways later, but one of the ways you can call this is by passing to columns a mapping of old name to the name you want it to call. So we want to rename tpep pickup date time to pickup. Okay, so these are however many mappings you have, and then you assign the result back into taxis. And now if we look at the columns, you see now pickup and drop off, right? Whereas before, tpep pickup time, tpep drop off time. Okay, so that's going to be much easier to work with. Okay, so now that we have the columns cleaned up a little bit, we have fewer columns first of all, and we've renamed them. Now we can look again at the data types. Okay, so if we just do .d types like we saw before, does anyone see anything that is bothersome with this? Some of the types here. I see a nod. Do you want to share what it is?
Our data type for the two that we just renamed.
Yes, correct. So the data type for the two that we just renamed, the pickup and drop-off time, these two, these are object, okay? But that very much looked like the correct format for a date time, right? ISO format. So what's going on here? Like, we definitely want those to be date times, right? It's much easier to do analysis on them if they're the correct type. Okay, so we can fix that, okay? So with Pandas, they have a PD2 date time function, okay? And you can pass in the series there, and by default, it's going to work with the ISO format, which is what we have. So we can just pass the string, it's automatically going to know how to convert it. If we think about the media rights data, that was not a standard format at all. So that we can't just pass it. We have to also tell Pandas what format it's in. But we don't even know what format it's in, right? So that's going to be the other challenge. So in order to actually apply this change, we're going to select the two columns that we want to update, so pickup and drop off. We're going to call the apply method, so it's going to say, okay, first run on pickup and then run on drop off, and what it's actually going to run is the function you pass inside, so to date time. And then we assign this back in, so we're just replacing those two columns with the version of them that is a date time. So now if we look at taxis D types, we now see that we have fixed these two, right? So now instead of saying object, they are date time 64. And now we can do a lot more with those because of that. In this case, everything else is probably where we want it, but there's some times, and we'll see in the exercises, that you might have, for example, a string and you want it to be a number. So for that, you can use toNumeric. And what that will do is it will be able to distinguish between whether it needs to use floats, for example, or if it can use integers. So if you have any missing data, it's going to have to use floats, and it will figure that out for you instead of erroring out. But there's also this as type, which if you want the error out behavior, for example, you can use this one. It's a lower level method. Okay, so now I want to talk about how we can create new columns in our data. Okay, this ends up coming up a lot. You might want to create columns based on current columns in your data set, and we can use also intermediary calculations, and we'll see that here. So for this data, we're going to calculate how long each of the taxi trips was. We're going to calculate the tip percentage. So we have the tip amount and we have the total amount, but we don't know the tip percentage. We're going to get the total of the taxes, tolls, fees, surcharges, so basically everything that wasn't just the fare and the tip going in. And then also take a look at how fast the taxi is going. So that's all information we can get from the turn data, but that's not actually there. And this is another one of the really useful functions that or methods that you will see with Pandas is the assign method. Okay, this is one thing where it does a lot, just like query. It's very, very helpful to have up your sleeve. It can actually make all of those columns for us in a single call. Okay, so we say taxis.assign. And then the important thing is to understand how the syntax actually works here. So on the left side, we always name the argument here as the name of the column that we want, either to create or to overwrite. So there's no elapsed time in the data frame currently. So that means that this is going to create a new column called elapsed time. Okay? And then what we set it equal to is it could be either just a static value. You can see equals 1, and then a whole new column is created and they're all value 1. You can use a function like we have here where you're dynamically calculating what that should be. So because pickup and drop off are now date times, we can subtract them and get a time delta, right? So we're going to use lambdas here. Is anyone not familiar with lambda functions? Okay. Yeah, so lambda functions are anonymous. So nowhere did I say that this is the trip time calculator, right? So it's a kind of a throwaway thing. I'm only ever going to be using it here. So I'm just saying shorthand, you're going to take whatever data you're given, which is going to be the data frame for anything in assign. And then you're going to take the data frame, so the data frame is X. You're going to take the data frame's drop-off column, and you're going to subtract the data frame's pickup from that. So you've been given the data frame, and you extract the two series, and you subtract them, and then you return the result back, which is a new series. That series is now injected into the data frame. So this happens sequentially. So the first column that ever gets adjusted or created or whatever, when you call assign, is this one, okay? So now, we now have an additional column in the data, and then we calculate the next column, which is the cost before the tip. Now, I said we needed 4 new columns, right? But you'll notice I'm actually creating 5. And that's because in order to get the tip percentage and the fees, for example, I need to know the cost before the tip, okay? So that's what I'm calculating here. Cost before the tip is going to be the total amount minus the tip amount, okay? This line finishes. At this point, we now have 2 new columns added to this data frame. And then we calculate the tip percentage, okay? And at this point, this is where using lambdas really makes the difference here. So if I didn't use lambdas, and I said taxis.tip amount divided by taxis.cost before tip, the whole thing breaks. It doesn't work. Because taxis does not have those columns yet. And it doesn't have them until we hit this line of the code, right? So we're still up here. So if we tell it to use lambdas, then it's going to pass in the intermediary result, okay? So the lambda x, when it gets x for this lambda here, this x is taxis, exactly taxis. This one is taxis with the elapsed time column. This one is taxis with the elapsed time and the cost before tip, right? And then we get to fees. This one is taxis with elapsed time, cost before tip, tip percentage. So it keeps building up, okay? And then at the end, then taxis actually has all of that data when the assignment finishes, okay? And you can also try this out on your own. Like if you don't believe me, you can just get rid of this lambda x and put taxis dot, and you're going to have a massive error. It just doesn't work because it's never been reassigned. Okay, so Pandas is able to keep track of the intermediary value in the assign, and only at the end does it get returned to you your data frame back with all the changes that you made. Okay, so our fees column, right, is the cost before the tip, so that intermediary column coming from here minus that fare amount, and then the average speed is going to be the trip distance divided by the elapsed time, which we created up here. And then here, remember how we did str to access the string functionality? This is a date time, so we have to use dt to get access to this total seconds method. Okay, so it's basically namespacing. Okay, and this gives us the average speed. So once all of that comes out, we now have taxis, and we can see we have the 5 new columns added. Right? We have our elapsed time, cost before tip, tip percentage, fees, and the average speed. Okay. Okay, so let's, actually was there one? Yeah. There is also something interesting that we will see later coming up with the elapsed time. So let's take a look now how we can sort the values. So now we have all the columns we care about, and we can now start using them. Okay, so the sort values method, this is going to take in the columns or list of columns that you want to sort by. Here I'm sorting by both passenger count and pickup. Okay, and by default these will both be ascending order. And the way it works is that the first column is used, but then when there's a tie, it goes to the second to break the tie, and then potentially third for however many you name. Okay, so I'm going to sort passenger count descending. So I want the largest passenger count at the top. Right, so that's this ascending false. And then break ties by the pickup time, and just so we can see the difference, sort those in ascending. Okay, so the maximum size of these cabs can fit in this data set looks to be 6 people. So we have tons of records here. But we can see that the pickup time are in chronological order because we used ascending true on these. So you can combine a bunch of these however you need, however many columns you need to accurately sort this data. Okay. So something you might potentially want to do if you hear about sorting is then think, oh, I'm going to sort and then call head, or sort and call tail. And you don't actually need to do that. So there are two utility methods instead that you can use, n largest and n smallest. So for here, I'm taking a look at taxis. I want to grab the 3 trips, so the first value here, 3 trips, with the largest value for elapsed time. So does anything seem wrong here when you look at that result? Yeah, exactly. It's almost a day. That is a very, very long taxi ride, right? So maybe the meter was just left on when they were parked and the guy had the day off or something. I don't know, right? But again, data integrity issue, right? If we hadn't added these columns, we would never have known that this type of thing was there, right? So this makes it very easy to grab that information out. Okay. So now we're going to start the exercise, this time using the meteorites data. And this is going to help us getting closer to finding some more data integrity issues in that file. Okay. So again, call me over if you need any help.
based on this, we can create our first feature. So our first feature we're going to create is aggregate. And that's pretty simple. There are structures. It basically is a bit more than that. And that is going to give us with that aggregate button, we can also how it turns on it, it's give it a distribution feature. As we saw earlier, this building, this is almost based on this one document. Really, we are going to this feature. This is how it is. Into a property here.
So who's still working on that one? Do you feel like one more minute would do, or you want to move on? No? Okay, let's let's move on. Okay. Okay, so I guess I'll read so first thing we have to do, we want to read in the meteorites data, right? We're going to rename the mass column so that we don't need to type the space in the parentheses anymore. We have to drop latitude and longitude, and then sort by mass in descending order. Okay. So again, we start by importing pandas as PD. We use read CSV to target the meteorite landings, and this gives us our meteorites data frame. So that we've saw before. So now I'm just going to tackle sequentially the asks. So the first thing was renaming the mass column. So we take meteorites and call the rename method, and we pass to columns a dictionary where the key is what they're currently called. So we're currently targeting mass, space, open parenthesis, G, close parenthesis, and we want to rename that as mass. Okay. This is going to return a data frame. So we can chain. This is a particular thing that Pandas does a lot of method chaining. So because everything is returning a data frame, we don't need to keep saying meteorites equals meteorites.rename and then meteorites equals meteorites.drop. Okay? So we've renamed. That returns the data frame with that renamed. And then we call drop on it. And we pass the columns that we want to get rid of. Here, I'm just taking advantage of the fact that we have 3 latitude-longitude columns. We had the geolocation, which was the tuple, and then we had the lat and longitude, right? And those were the last 3. So what you can do is you can take the meteorite columns and you can slice it to get the last 3, okay? And then this means that we're just passing to drop the names of the last 3 that we want to get rid of. This again returns a data frame, and on that result, we're going to call sort values. We're going to sort only by the mass, and we're going to sort descending order, so we say ascending equals false. This again returns a data frame, and after that finishes, we then assign it back into meteorites. So then we can say meteorites.head, and we have the first 5 of this modified data frame. You can notice here, mass has been renamed, and we remember Hoba was the largest, or the heaviest meteorite in the whole data set, and that is indeed now sorted to the top because we sorted in mass descending order, and there's nothing beyond the year column. So those last 3 columns, which were the latitude and longitude information, are all gone. Any questions on this? No? Okay. Okay, so now we're going to see some other things.
Is it true that, like, for really large data frames, you want to chain like that just to avoid making, like, is it making copies if I keep saying meteorites equal to meteorites?
Yeah, well, so each time you're returning one, that other thing is then getting assigned, and then you're again assigning and again assigning. You're just reusing that intermediary thing. It's also just cleaner, like having, because then what people sometimes end up doing, oh, meteorites 1, meteorites 2, meteorites 3, right? With each little transfer, and then that really gets out of control with the memory usage. Yeah. This is also just cleaner because you can think about it as you're having, when you use chaining, you kind of have like a pipeline of how you process the data, right? So instead of having, oh, this is my rename and then this is this, you just say like the data comes in, I perform my transformation, and now I have it for my analysis. Okay. Okay, so if we take a look at the taxis data, right? So before this point, our row numbers were the index. We can control what information goes on the index by calling the setIndex method. And we can give it 1 or more columns that we want to use as the index. So here I'm setting the pickup time as the index. So already now we have a new type of index. Before it was just numbers, 0 to whatever, right? And that was called a range index. When we put date times there, it's a date time index, and it has different functionality, which we'll see. So notice that now pickup is over here, right? It's not at the same level as drop off anymore. It's been moved into the index. We have the same values, and notice also that the row numbers are gone forever. Those are gone forever. Unless you read the file in, if you just do this operation, they're gone, okay? We'll see how you can recover that later, but that's an important thing to keep in mind when you use setIndex. Okay, and we've assigned this back to taxis, so we now have this information in the index. So now if I said, well, I want to sort by pickup time, we can just call sort index, and it's automatically going to sort by the values in the index. We don't have to say pickup time anymore, because whatever's in the index is going to be sorted. Also put this tip here, like if you wanted to sort your columns alphabetically, it's an index, right? So you can still sort it. You just need to tell Pandas, by default, it's going to work on the row index, and you want the column index. So you can play around with that later. So one particularly neat thing that you can do when you have date times is that you have a different style of slicing that you can use. And so here I'm selecting all records, and again, remember this is a small sample from a much larger data set. So I'm saying, give me all the taxis that had a pickup time between October 23rd, 2019, 7:45 a.m. and October 23rd, 2019, the 8 o'clock hour, the entire hour. So the way these work are, this is like, you can think of whatever's here is the fixed value that must match, and anything else is a wild card. So 8:59:59 matches this, okay? But 9 does not. It's beyond that window, okay? And we can see it here, 7:48. This is after the 7:45. We have 8:02 and 8:18. Everything else was beyond that range. So you can extract particular bits of time. If you think about something like maybe you're working with sales data and you want to extract Q1, right? That can also be done with this, and we'll see that later. Okay, and if you're not using the range, like in there we wanted between 7:45 and then through the 8 o'clock hour, if you only want the 8 o'clock hour, you're not, like how would you get that with two values, right? We saw that the end value was inclusive, so if you would, instead of having to type 59:59.999 for all like the nanoseconds, whatever you can have, instead you can just use lock, and you would put the single value. So this one says, give me everything from October 23rd, 2019 in the 8 a.m. hour. And right, if we look at this result compared to the one before, we had 3 results before. Only one of them was in the 7 o'clock hour. So now we just get the 2 that were in the 8 o'clock hour. Okay? Okay. So we now played around with the pickup time. I mentioned before that if we set the index again, we would lose the index unless we did something to save it. Okay? We don't want to lose the pickup time because that's very valuable here. So if we were done with it in the index, we can call the reset index method. And now notice pickup is back over here. We once again have 0, 1, 2, whatever. But remember that 0, 1, 2 now, because we've sorted the data, is no longer the record in the original data. So most of the time when you have like 0, whatever, just keep in mind that that index does not mean anything to you. If it meant something to you, you'd probably name it or move it into a column. So just be careful of that. And you may be asking yourself, well, why would you ever need to reset the index? And you'll see later that certain operations that you do with Pandas will push information that you genuinely care about into the index, like when you're pivoting information or summarizing things, which we'll get to in a bit. And then maybe you don't want to lose that, so you want to reset it. So this is something that will come up quite a bit, of the need to reset an index. Okay. So now we're going to do another exercise. And here's one where, if you have time, you can hunt for a data integrity issue in the meteorites data set. I'm just going to get some more water, but I will be back if anyone has questions.
So specifically, the game here, and it includes rule factor, which we use for algorithms. So for example, if the evaluation is 2, then white is out 2 columns essentially, we are going to, this will allow us to distinguish it from square two minus but it's not the minus
How are we doing on that? Did everyone manage to do the main part? Not so much find the issue? Raise your hand if you're still working on it. Not finding the data integrity issue, but
I think we have found the data integrity issue trying to do the other thing.
are we good if we walk through it? Yeah? Okay. Okay. So we're taking our meteorites data, and the first thing we're going to do is we're going to make the year column not have this ambiguous date that we don't really know what it is, and just make it have the year. So, and we need to convert that then, once we have extracted that bit, to a data type. Now, I very much hope that you were reading the hints, because if you don't do that, you will have a much, much harder time getting this to work, because there is extra trouble in there, but that is not the data entry issue. And then after that, we were creating a new column that is just going to be a Boolean indicating whether it fell before 1970 or not, and then setting the index to the ID of the meteorites, right, which we were just talking about before, is unique for each of those meteorites. And then we're going to extract the rows for a particular set of IDs. Okay, so we read in the data, right, with pd.readCSV as we've been doing before. Remember about the chaining, right? This returns a data frame, so we can immediately call assign on it. And here, the year column already exists. So what this is going to do is going to update it. It's going to change it to the new value, okay? And what we're saying to do here is, following the hint, we're going to take the existing year column, which is a string, so we're going to access string functionality, .str, right? And then we're going to use the slice method, which was in the hint to use, right? So we don't know what format those were in, but it was always, 2-digit slash, 2-digit slash, and then the year, right? So the position of the year is index 6 to 10. So if we slice that bit out, this gives us, for each meteorite in the database, the year as a string, okay? And then we can pass that to pd.toNumeric, okay? And we're using toNumeric here because if this substring is empty, if there was no year, right, we wouldn't be able to make an integer column. So pd.toNumeric is a way for us to create a numeric column and have pandas decide if we need to use floats in the case of nulls, which we do here, or if
It's going to take all of the remaining columns and realize that those are going to be the ones that are melted.
exactly, yeah. And so whatever ones were columns now become elements in a new column. That's basically just, it's almost like a lookup table. It's like, okay, this value, which year did it correspond to, or which column did it originally correspond to? Okay. So to fix the year bit, okay, we can also be a little crafty here in the sense that we don't want to be maybe like doing date calculation to figure out how far it's off or whatever. Because there's also an interesting thing in the data where they only show the last 365 days. So we started from 2021, May 14th, and it will go until May 15th, 2020, and then stop, okay? So we are just going to replace the year, and then with the year that is in the year column, okay? So we take our melted data, and we can use the assign method to update that column. So we're assigning the date, right? We're replacing what's already there. And here's where we do the trick. So first, we already know the format that these dates are in, right? So we know that this piece from dash month dash day is correct, and we want to keep it. And we just want to change the year. And the year, because it was a column name before, is a string. So we can concatenate that piece, so the string of the year, with the current date, but formatted to only have the dash month dash day, okay? So this pulls out this piece right here, dash 09, dash 12, and then we put the year from this column in front of it, and then that's now a string. So the string would, in this first row here, would be 2019 dash 09 dash 12, and then that gets passed into toDateTime, which we already saw can work with standard formats without us needing to specify. So that then comes out as a date time again. So this is still a date time, but it now agrees correctly, right? Everything in the date column has the same year as the year column. So at this point, we could drop the year column, and we would have transformed the data. But this introduces an issue, right? So I was saying we only have the last 365 days. So when we do the melting, because of the way it's making every combination of everything, you might have points where we don't have values. So if I take the TSA melted and I sort by the date, right, and I just looked at the end, then I would see there's no values for travelers. So I told you I grabbed this data, I think May 15th, 2021. So I couldn't possibly, unless I was NASA, have information about the future TSA traveler throughput, right? So this just is an artifact of doing that transformation, of it making every possible combination, because there was a date in 2020 for this date, and so that transformation happened, but there was no traveler count because it didn't happen yet. So we just want to clean up that artifact. And to do that, we have a drop NA method. Okay, so this is just going to remove any rows by default that have any null values. Okay, so you have to be very, very careful. Here, it was very obvious that that was just data that didn't exist. But think about the meteorites, right? We were still able to look at interesting things without needing all of the meteorites to have a geolocation, right? So you don't want to call drop NA on that, because then you lose a good amount of data, right? There were, I don't know, like almost 10,000 of the meteorites would have been dropped from a case like that. So in situations like that, you can actually have more complex criteria that you pass to drop NA. You can tell it maybe only drop if it's a NA in this particular column. Like maybe you're analyzing mass, so you don't want ones that have no mass because that doesn't do anything for you. So you can get rid of that. You can also do things like thresholds, like it has to be missing data from 75% of the columns, and then you remove it or something like that. So once we remove that, you can now see that the final date is the date that we had started being the last one. So May 14th, 2021, where no future data is present. So that's correct. Okay, so now if we go back to what they were attempting to do on the website was to compare a certain day across years. So comparing March 1st, 2019 to March 1st, 2020 to March 1st, 2021. Okay, so we can do something like that using pivot tables. So if we take our TSA melted data frame, and then just because I'm going to show this on the screen, so I'm going to query down to a smaller subset. So this query logic is just saying, give me everything in month 3, so March, and less than the 10th day. So the first 10 days of March for all years in the data. Once we have that, I'm going to create a new column because I need this to pivot, and I use the assign method. And this is just going to be the day. So the same calculation. We take the data, we grab the date column, DT for date time, and then grab the day. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I can do the pivot. So the pivot is another reshaping. Melt was collapsing them in, and then you can think of the pivot as stretching them out. Okay? So I'm saying here that I want Pandas to place each unique value of year in the index. So we know we have 2019, 2020, and 2021. And that ends up down here. Okay? And then for columns, we want Pandas to place each unique value for the day in March, which we know is 1 through 10, along the columns. And that's what we have up here at the top. Okay? And then the actual values to show at those intersections, so at the combination between the year and the day and the March, we want to show the traveler count. So that ends up in each of these values. Right? And then we could compare, if, for example, if you wanted to see the first in March year over year, you could just look directly down and you can see that this one is much smaller, as is this over time. That's just something you can look into later. Right? We're dealing with a simple index, so we have one column in our index, but you could have multiple ones, and then you have to do slightly different operations, stacking and unstacking. So another reshaping option we have is transposing. So while I could just say that this one is columns and this one is index, and then have the reverse, you can also just call .t, and this also is from NumPy, so you're just transposing the rows and the columns. And so this is the exact same results before, but now to compare year over year, we go across the row instead of down the column. So this is also particularly handy if you're doing like a big pipeline of transformations, you're adding a lot of new columns. You saw how it stretched all the way to the side, but maybe you're only showing 3 records. If you just do a .t, then you have a nice vertical display of everything you can see, and you're not like running off the edge of the screen, right? So this is very handy for just displaying things in a better format. Okay, so now we're going to add some more context to that TSA data, right? So just looking at individual dates, right, tells us on that exact date, but maybe we wanted to compare, for example, holiday travel year over year, right? So maybe we want to see, did significantly fewer people travel on Thanksgiving in 2020 and 2021 because of COVID, right? And to add that information, we need to merge in additional data. We need to know when the holidays were, and then we can create a buffer before and after it, and so we can group that whole thing instead of just Thanksgiving, for example, as Thanksgiving travel, because most people aren't traveling Thanksgiving morning and then returning Thanksgiving night, right? They're traveling before and after. So to capture that, we need the area around it. So first thing is we're going to read in a holidays data set. And here I'm saying parse dates equals true, not parse dates equals the date. And the reason is because I'm also telling Pandas, when you read in this data, set the index to the date column right away. So I don't have to bother setting the index. And so these two in combination sets the date column as the index and makes it a date time. So that's all taken care of. And so if I read this in, and remember with the date times we can do neat things. So if I just say show me everything in 2019, these are the holidays in 2019. Our index has the date of when they were, and then the actual holiday name is the value. Okay. So to actually add this to our data, we're going to take our melted data set, and we're going to call the merge method on there. And if anyone is familiar with SQL, this will be pretty much exactly the same type of logic that you think about. So we have our left side, which is the data frame that we called merge on. So that's our TSA data. And then we pass in the right side, and that's holidays. Okay? And then you have to say, how do you want the merge to be performed? Okay? So the first thing is, since we're matching, if you look back here, this is an index, and we're matching it to the date column. Okay? So in order to make that happen, we have to say, on the left data frame, use the date column. On the right data frame, use the index. And so at that point, Pandas is now going to line them up. It says, okay, January 1st, 2019 in the index maps with January 1st, 2019 in the date column in the TSA data. And then we just need to say, how do we want the join to be performed? Okay, so here it's very important we say left join, because we want to make sure we keep all the data in the TSA side, which is the left side. If we have an inner join, for example, then we will only get the data on each of those holidays, and we will lose all the data on non-holidays, right? And so that's the main thing. And so we're allowing nulls to come in, like here, right? There's a null here because there's no holiday on January 2nd, 2019, right? But if we had done an inner join, this entire row, all of these 4 rows would be deleted. Okay? So the left join allows us to tack on this extra information, and so now we know that this was a holiday. Okay. So now, I was saying before, people aren't traveling home, or there and home on the exact same day of the holiday, right? They're going before and then coming back after. So to make that part happen, we need to fill in some of these NANs, not all of them, with the holiday that they correspond to. Okay? So what we're going to do is we're going to fill a certain number of days forward. So we're going to carry it forward. So like this one, we're going to say is New Year's Day also. And then the day before New Year's Eve, before New Year's Eve, so the 30th, we would also count as New Year's Eve, because people might be traveling beforehand. So to do that, we take advantage of the NAN filling logic, okay? So we take our data, we call the assign method, and we're updating the holiday field. So we take holiday, and then we take ffill for forward fill, and this is going to basically be like a cascading forward until, like, start filling the second you see an NAN and don't stop. But we want it to stop, right? So we say limit 1. So you can only fill the holiday 1 day after the holiday. And then also we want to backfill, bfill. And this is then a limit 2. So I'm saying you can count it as a holiday if it's up to 2 days before the holiday or 1 day after the holiday. So that's the buffer around the holiday. Okay, and so here's what this looks like if I'm just pulling out in 2019 Thanksgiving or Christmas. Okay, so this one is actual Thanksgiving, but we're counting these 2 days before as Thanksgiving travel, and then the Friday after as Thanksgiving. And you'll notice that with Christmas Eve and Christmas Day, right, so this was real Christmas Eve. We don't have anything after that because that wasn't null, right? So we keep this as Christmas Day. So Christmas Day propagates once forward, Christmas Eve propagates twice backwards, but they don't overlap each other. You're only replacing null values. Okay, so now we can do some aggregations on this. So we can make a pivot table. Year is going to have the unique values, the index is going to have the unique values of year, so 2019, 2020, and 2021. Columns, we're going to put the holiday on the columns now. So New Year's Day, Memorial Day, July 4th, etc. I'm saying sort equals false because we know that the data is in chronological order and we want to see the holidays in order because this gets confusing. For example, if you see like Labor Day before New Year's Day and then Christmas Day before that, and it's like if you looked across, you can't really kind of just gauge, is there also like a yearly effect going on if you look across the row. The values we want to have are the travelers, but this time we need to tell Pandas how to aggregate, right? Because Christmas Eve is 3 days. We had the 2 days before. Christmas Day was 1 day afterwards, so it's 2 days. New Year's Day, a better example would be Memorial Day. Memorial Day would be 4 days, right? 2 after, the day itself, 2 before, the day after, and then the day itself, so 4 days. So we want to have the total Memorial Day travel and not just the travel on that. And so we need to say the aggregation function is the sum. So that will sum all the travelers on the days that have been tagged as Memorial Day, okay? And so now we can see, for example, if you compare Memorial Day in 2019 to Memorial Day in 2020, the big drop-off, right? Why are these all NaN? No data. Yeah, exactly. Right, so the data stopped May 14th, 2021, which was before Memorial Day. And that's also where this sorting is nice, right? Because if you didn't have that, then you'd have like NaN, 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 suddenly a number, NaN, NaN, right? So that it gets confusing. Yeah, so, and you can also see like something like, you know, Christmas has much bigger drop-offs because we're seeing the effect still happening. So one thing we might want to do is, instead of looking at the raw values, looking at percentage change. How much was the year over year now that we have basically that exact logic in place? We just tack on PCT change. And here we're just saying the fill method is none so that it doesn't start calculating them, like giving values for these or these. We want it to be that there's no data to compare to, so you don't make anything. So you can see here that Memorial Day, right, had an 88% drop-off from pre-COVID to 2020, right? And then if you have more and more data, then you could potentially see, oh, which one was the first time where we saw back an increase over there. And it was not here yet. Okay, so for the next one, we're just going to change a little bit of how Pandas displays things. So you may have noticed that, like, here, for example, there's no like 1,000 separator or anything. The numbers are not huge yet, but the next thing we're going to do, they're going to get big enough that Pandas is going to decide to use scientific notation. And so to suppress that, we're going to do this. So we're just going to set the option for how it displays floats. And this is just saying to use a comma as 1,000 separator, and then 0 digits of precision, because in this case what we're going to do, we know that they're integers, and so having that 0 is not helpful. And then this is going to be applied for us. So what we're going to do here is one thing that maybe was bothering you is the fact that Christmas Eve and Christmas Day are separate, right? And New Year's Eve and New Year's Day are separate, when it's really the same holiday that the travel is for. And so we can address that here. So we need to import NumPy first. Then we can take our data, and we're going to call assign, because we need to do a calculation first, because you can't combine New Year's Day 2020 and New Year's Eve 2020, because they're actually different years, right? So you need to calculate for wrapping over the year. And so here what we do is we just say where the holiday is New Year's Day, you're going to subtract the year, so that now it's going to be counted with the New Year's Eve of the year prior, where it actually is part of the same holiday. And then we are going to update the holiday itself. And here we again use NumPy where. So the way I should explain that first. NumPy where, you have a operation here that is, again, a Boolean mask. It's true or false. If it's true, you take the value, the first value here. If it's false, you take this one, right? So we were only subtracting the year if the holiday was New Year's Day. Otherwise, we left the year alone. Okay. So for the holiday, we're saying if the holiday contains the word Christmas or New Year, then we want to replace day or eve with an empty string. Otherwise, we keep the holiday exactly how it was. So that updates the year and updates the holiday. And then we can do the pivot table that we had before. So unique values of the year column in the index. Notice now we now have 2018 because of that, right? Because New Year's counted the one before. Just the New Year's Day for 2019. And then the columns, we now have holiday. So we still do the sort false, but notice that now New Year's is at the end and not at the beginning and at the end, right? So it's been lumped at the end where we would expect it, and the first is now Memorial Day. We still have, this bit is exactly the same, where we take the travelers and we aggregate with the sum. These two things are new. So margin's true. This is an easy way for you to get these totals down here, the subtotals. Okay, and then margin's name just says to call this total. So I'm saying call this total. I think default might be like all or something. So here you can see the total holiday travel in 2019. And for here you can see the total holiday travel for New Year's across the entire data set. And so this bit here is reordering to move New Year's to the end. That's all that is. But yeah, so now you can compare. And also notice, again, the formatting, what we did here. So we have the comma as the thousands separator because of this bit of code that we had. Right, so right here, 9 million, we have the comma, 720,000. And so that makes it a lot easier to see. And then when you're done with changing any of those options, you can just reset it. Another option you might find helpful is one, I don't know the name off the top of my head, but the same kind of logic applies, where if you have a lot of columns in your data, after a while Pandas just does ... and then you don't see the columns. So you can actually change the threshold for the number of columns that it takes to start showing the ... So maybe the limit is 11, right, or 12, and you have, 13 columns. That's really a pain, right? So you might just change it. Just please show me that one that you're hiding in the middle, right? And so you can do that. And that's what that link there is for. All right, so let's do another exercise now. All right, let's go over this one. So the first thing we had to do, right, we had to read in the meteorites data. We had to create a pivot table where we wanted to show both the number of meteorites and the 95th percentile of the mass. So showing two different types of things was not something I explicitly showed, right? So that's where you had to see, does this method, can this do that? And so you had to be a little curious. And then we were going to just look at 2005 through 2009 exclusive. So here's how you could do that. So the first few lines up here are what we had from previous exercises. So basically just getting the year column correctly. And then from there, the actual exercise here, first thing I'm doing is filtering down to 2005, 2009. So I have the query method. And here's also another neat thing you can do with query is that you can use what you would have to, like before, if you did like meteorites.year.between, whatever, you can just, again, chop off the meteorites bit. So you can say the year column, use its between method, and then 2005, 2009. This is inclusive by default. So this, after this bit, we have only the years that we care about, and then we can call pivot table. So I'm putting the index to have the unique values of the year column. You could switch this with the columns, it doesn't matter. And I'm putting the unique values of the fall column in the columns. So we know fell and found. And you'll notice that we have fell and found twice in the result, right? So this is an example of what I was talking about before when you have multiple values in the index. So it ends up having this like tree breakdown, right? So from count, the found value is this, whereas the 95th percentile from found is over here. The values that we were looking at were just the mass column, so that's what we say for values. And then this was the bit I was hinting at earlier, is that the aggregation function, before we only gave it the sum, but you can give it any number of aggregations you want to perform. So here it's just a list. I say you can take the count, and also you can grab the 95th percentile, right? The difference here is that count is already available, so I can just give it a string, but the 95th percentile does not exist as a method we can just use. And so that's where I'm passing in a function. I'm using a lambda because I don't want to create a 95th percentile function because I'm not going to use it anywhere else. And then that's where I actually need the rename. Because when Pandas makes this column, it's saying, oh, what is the name of this function that you called? Let me use that as the column. Lambda has no name, so it ends up naming, before I do that last line, this ends up saying in the angled brackets, lambda. And then you hand this to someone as a report, you even don't remember what it means in 10 minutes. So just tacking on the call to rename and explicitly renaming lambda's name with 95th percentile, and that's what makes that show up down here, like that. And so there you have a slight variation on how you could use the pivot table to get more information. Definitely check out the docs. There's other things that you can do as well, but I just wanted to make sure you saw that was another thing you can do. Okay, so let's take a look now at crosstabs. So this is more of like counting things. So in the sense of like here we have a frequency table. So instead of just looking at the raw numbers of traveler throughput, I didn't want to see is like, was this day a high traveler throughput day or a low traveler throughput day? And we could do that as follows. So we could first we have PD crosstab, and then we need to tell it the index, the columns like before. So what is it counting? And it's counting the years. So we're giving it the year series, the unique years. And then the values that it's going to use for the index are going to be low, medium, high. So this is a new piece of code here, the cut function. So this is going to divide up the data into bins of equal width for you. Okay? So the data we want to divide is the traveler count. We want to make 3 bins, and we want to label them low, medium, high. So nowhere did we have to figure out where the bins were. Okay? And then that is going to end up down here, so low, medium, high. And in order to have this understandable what this is later, we've said row names equals travel volume, and that ends up right over here. So this gets us that bit. And then we have our counts. So 2019 has 0 days of low travel volume. 2021 has 0 days of high travel volume. Does anyone have any issue with these facts? Sorry? Yeah, so it does, yeah, right, it is odd, right? Because we know in this data there's huge, huge dips, right? So comparatively, we wouldn't expect, looking across the whole data, there wouldn't be any low in 2019. But we might potentially want to consider this relative in 2019 when there are any low days for 2019, right? So that's the thing where the data doesn't make sense looking at it, depending on what you're trying to do across the whole thing, right? You need to decide, am I interested in, like obviously this is expected, you would expect mostly low, you know, during the COVID times and then mostly high before. So depending on what you want to do, you have to be careful about how you calculate the bins that you're going to do. So we're doing the bins, low, medium, high, across the entire thing, which means that we will never have a low travel day in 2019 because 2019 was pre-COVID and all the other data is affected by reduced travel during COVID. So another function I want to call out here is so cut was doing like raw values. So it's saying, you know, starting from 0 to 100, if I want to make 10 bins of equal length, it's intense. But it might be that all of your data, like think about the meteorites, where it was not evenly, it's not an even distribution, right? There was a lot of skew. So if you use cut, then you might have one bin has 95% of the meteorites. Some bins have 0, and then occasional has like whatever. But what you might want to do instead is have all bins have roughly the same number of values in them. And so you can do that with Q-cut, which is quantile cutting. Yeah, and this is just mentioning that just like we saw the aggregation function, you can also control what kinds of aggregations you want to call, or want to use when you're aggregating values with crosstab. Definitely check out the documentation. It is a really, really powerful function. Okay, so let's talk about grouping operations now, okay? So far, right, we were in a state where we were comparing maybe the entire column. We were saying, what's the mean? What's a low volume travel day, right? But that stuff might vary by year. You might want to, like, within the year, what are the mean travel volumes and what is high for holiday travel and low for holiday travel, etc. And the only way to do that is by using grouping. Okay, so what I have here, I'm taking the holiday travel data, and I first, before calling any summary statistics, I say group by year, okay, and then call describe. And here's another use case for include, what we were talking about much earlier, where we had include equals all. So here, include is any numeric value we want. This is so we remove the dates. We don't want to be performing aggregation on date times here because that's not helpful. So this now, instead of describe having the information about the traveler column across the entire data set, now shows us year by year what are the summary statistics. So for example, you can easily compare what was the minimum travel volume on any one day across each year, right? So you can see this number in 2019, a much, much lower number in 2020, and etc. So you can actually compare the entire distribution easily from that. And it's a very, very short line of code here. The only difference, like I said, is we just add the group by before we do the calculations that we want. So one other thing that you might take advantage of, like with the group by, is we're talking about like top travel days, right? You can perform a rank calculation within the year and then pull out the top ranking days across all the years and compare them. And that's what we have here. So we take the data frame that we've been working with, we use the assign method, and we create a new column, which is the rank within the year. So was it the number 1 most traveled day, the number 2 most traveled day, whatever. So that is calculated by using group by year, taking the travelers column, and then calling the rank method. We rank ascending. So rank number 1, so ascending false. So rank 1 is the day with the most travel of that year. And then we can use sort values like we saw before, and we can use the tie-breaking logic. right? So we can sort first by travel volume rank. So that pulls all the ones. And then we can sort by year, breaking the tie, so that we have 2019 first, then 2020, and then 2021. So if we look at this, we can see that in 2019, the highest volume travel day was the day after Thanksgiving. But it was not a holiday in 2020 or 2021. So why was this particular date in 2020 the top day? Does anyone have any idea? February 12th, 2020. It's not a holiday, right? Oh, okay. Well, sorry. I'll have to add that to the slides. You're missing the bigger picture here. It's right before COVID shut everything down, right? This was like a month before things were like completely dead. So probably it was like the panic where it was already starting. People are now not air traveling anymore. They're doing other things. There's restrictions on where you can go, right? And then the other thing is 2021. So the number one travel day here was May 13th, 2021. And I collected this, the last date in the data is May 14th, 2021. So this is now also telling you that, oh, things were probably picking back up again, to that we've already had the number one in this, near the end of where we've been collecting. So you, like even just this, right, there's another like insight you can get from this. So rank is a helpful thing. You won't always need to reach for, but it's a nice thing to know how to do. And combining with the group by, you can do some pretty powerful things. Okay, so now we're going to see how we can now call multiple aggregation functions, right? We saw describe, or we saw just calling rank, for example, but there's a way to do more. So let's say we now want to compare travelers overall across years. We want to compare holiday travel versus non-holiday travel. And so here we have to do some extra legwork, okay? So the first thing is we only have a travelers column right now, and then we have a column that tells us if it was a holiday or not. So in order to get a column that is holiday travelers and another column that is non-holiday travelers, we need to create those. So to create holiday travelers, we're going to use the numpy where function again. And remember, the first bit is the true-false logic. So this piece here, the tilde negates, remember. So this says where the holiday is null, but negated. So this means where it was a holiday, we want to take the traveler count. Where it was not a holiday, we want to put not a number on purpose. Does anyone want to guess why we would want to put NaN there? Think back to like what we talked about, null island and 0, 0 and stuff like that. Exactly. And so it's not included in the aggregation. So for example, if we said, well, it's not a holiday, so 0, then you calculate the mean over all that, and now you have all these zeros, and your actual mean is way lower than it should be. So by making it not a number, you then make sure it's excluded from that calculation of the mean later. And if you're curious, you can test it out. Like look at this slide, change those to zeros, you're going to see dramatically different numbers. So then for the non-holiday travel, it's just the reverse of the logic. So here, when it is not a holiday, right, then we take the traveler count, and otherwise we have the null. Okay, so with those two updated here, I'm setting the year column to numeric. And then it's mainly to do this bit here, where I'm basically telling Pandas, only take the columns that have numeric data types. So instead of manually saying, take the year, take travelers, take holiday travelers, take non-holiday travelers, this is just a shortcut. So grab all the numeric fields. At that point, we can group by year. And then before, we would have called like mean or describe, but I specifically only want mean and standard deviation. So we can use the agg method. And just like we saw before with the aggregation function to the pivot table, you can pass a list in here. And for each of those, it will make the aggregation. So for each of our numeric columns, we're going to get the mean and the standard deviation. So now, for example, you can compare the holiday traveler standard deviation versus non-holiday in 2019, or even across years, right? You can look at Like you can even see right here, right, the order of magnitude difference here. Okay. So that previous example, we were doing multiple aggregations, but they were all on the same type of data. They were all numeric data, right? We saw when we did describe, like mean on a categorical field was NaN. It doesn't mean anything, right? So how could we do aggregations where we have some categorical data and some non-categorical, some numeric data? So here we just have a slight change to how we call the ag method. So instead of passing in a list of functions that will get applied to every column, we then explicitly target what aggregations we want to perform on which columns. So here we say, take the holiday travelers column and then calculate the mean and standard deviation. For the holiday column, which is categorical, it's the name of the holiday, we want to calculate the number of unique and then the count. So this tells us, for example, that in the data we have for 2019, we captured 8 holidays for travel and 26 days of holiday travel. And we can easily see here that we have partial data in 2021. So we can see that we only had 1 holiday captured in this data set, right? And then we can see the count of the number of holidays that were there. And then again, you can compare the means, for example, across these years still, because that aggregation happened. So the mean and standard deviation only happened on the column that we specified, and likewise for the categorical aggregations down here. Okay, and this is just some other things you can do. You can check this out later of like other specific ways of like you need to target things on an index or you want to group by quarter of the year and stuff. There's tons that you can do with the group by. Okay, and let's do another exercise. So this is going to be a very, very short solution. So if you find yourself doing something complicated, you're barking up the wrong tree. So, yeah, so let's dive in. All right, let's go over this one. Right, so we had to calculate summary statistics just for the mass column, but comparing when the meteorite was found versus observed falling. So it's very easy to do this with the group by logic. Okay, so the first two lines were just importing pandas, reading in the file, we've seen that. So we take meteorites, group by fall column, which had fell or found. And then for each of those groups, right, we're extracting the mass column. If you renamed it, then you would use the renamed value. And then describing it. And so here we can clearly see the difference between, first of all, we know the counts were very different, but we can also see, which is interesting, right, the mean, how much of a difference there is between the mean of the ones that were found versus the means of the ones that fell. Does anyone have any thoughts as to why the mean mass for a meteorite that was observed falling is much higher than one that was found? Intuitively. Exactly. The ones you see are going to be bigger. It's going to be remember we saw the median was like 32 grams? Like, you're not seeing that, right? But like a very big one that then people are going to be reporting. I saw this massive thing in the sky, right? So you can clearly see the distinction here, right? And then also some of this is also going to come from the age of things. If they don't have records of people seeing it, then it might be that they just say that they found it. But a big thing will be that. Yeah, it'll need to be big to be seen. Okay, so with that, we'll move on to the final bit of the data wrangling part. And we're going to look particularly at some things we can do with time series. So we're going to go back to the taxis just for a little bit. And this time we're going to put the drop-off time as the index just to change things up, and then sort the index. So we saw that we can do stuff like this for the slicing, right? That we can put these expressions here, and then they're going to match everything that starts with this bit and beyond, right? So this would be anything in the noon hour through anything in the 1 p.m. hour. And we also saw that if we were just looking at one particular thing, we can use lock. But what happens if we wanted to do, like here you can see I'm looking at noon, but I have to limit it to 1 day. How would I say I wanted to look at the 12 p.m. hour on every day in the data set? Think of also like stock market data. Maybe I wanted to see the opening 5 minutes on every day for the week, right? That is much harder to do with this, but there's this method here called between time that lets you do exactly that. So here I'm just saying between 12 and 1, pull out all of the data bits, right? So here, this first one, October 23rd, and the other two are October 24th. So that allows you to then be able to compare across days at particular times. So this one, very helpful, again, if you happen to be working with like things like stock data. There's also at time. So if you wanted to go further, like I need to know what happened exactly in the final minute of trading or something, then you can do something like that. Okay, so that was just like to show at the time granularity some extra things, and now we're going to move back up to the date granularity, and we're going to go back to the TSA data. This time we're going to set the index as the date, which we hadn't done before. Okay, so one thing we can do is calculate change over time. We were comparing particular days, but you might want to see, like, are things trending down, especially as you get closer to when COVID shut everything down, you can kind of see the taper off of how things were changing over time. And likewise, when it starts picking back up, you might want to see the differences. And that's also simple to do with Pandas. So here, first, I'm just going to select 2020, and then just so we have a full year. And I'm going to make 2 new columns with a sign. One is the 1 day change, the day over day change. And to do that, we just take the travelers column and we call the diff method. And that will automatically subtract day over day. The 7 day change column is, we just pass in 7. So by default it's 1. This is now a week over week change. And if we just look here, we have these new columns that were created. Why is this one not a number? The 1 day change for January 1st, 2020. We have 2019 data. Because I've only taken 2020. Yeah, I was tricking you. Because I only selected 2020, so there's nothing to compare to. You were right, but then I tricked you. So, but yeah, it's exactly that. So you need to have something to compare to, right? So until you have that comparison within the scope, you're going to have not a number. So likewise, 1 day change has 1 missing, 7 day will have until we have the 8th day, at which point you can look back to the 1st day and do the calculation. So that's always going to be the subtraction. But if you wanted to do something else, or if you wanted to take other fields into account, there's this shift method, which allows you to do much more complicated transformations that you might need. Okay, and now we're going to take a look at something that's close to what we did with the grouping and aggregation, but there's a different interface into that, which is called resampling. So here we can take quarterly comparisons of the data, and in order to do that, I want to make sure that I have full quarters of data. So here we have a new type of selection here that we haven't talked about before. It's still the same logic. We're saying anything in 2019 through, and this is different here. So instead of saying a specific month, right, I'm actually just saying give me everything up through Q1 2021. So you can use Qs here, which is nice. So this will chop off everything beyond March 31st, 2021, because we have a partial quarter in there. Q2 is not full. Then we do that trick before of selecting only the numeric types. And then we call resample. So just like you would call group by at a point, you can call resample. And you give it the time frequency at which you want to resample. So the Q is for quarterly, and the E means anchored at the end of the quarter. So that's why it's March 31st, 2019, and not January 1st, 2019. Or it may even actually go beyond that. But this just makes it a little easier, so you can anchor it how you wish. And then just like we had group by, we called ag, you say resample, and you call ag. Okay? And we're saying we want the sum, the mean, and the standard deviation for each of those quarters. And so now, again, you can compare the total people that traveled in Q1 2019 over time as you wish. Okay. And then the final thing we'll talk about are window calculations. So kind of like the diffing logic, but there's a lot more that you can do. So we can do rolling calculations. We can do expanding windows. So think about a cumulative thing over time, like continuously adding more information, and then exponentially weighted moving windows as well. So just to illustrate a little bit of how that works, again, taking just 2020 data, using the assign method. Here I'm doing something different, right? I've always been saying the name equals whatever. This is a neat trick if you want to have characters that you can't have, like spaces. If you put a dictionary with the names that you want, so 7D space MA for moving average, and then you unpack the dictionary in the assign, it will work. And so now you can actually have this show up here. The best reason, which we'll see to do this, is plotting. It makes plotting a lot easier because you don't have to rename to remove the underscores. So the 7-day moving average, similar to how we've seen group by and resample, we first have to define where the calculation will be performed. So we say rolling 7D, rolling 7 days, and then it's going to, for each of those windows, it's going to take the travelers and calculate the mean. The year to date is that cumulative expanding calculation. So instead of calling rolling or group by or resample, we just call expanding. And again, take the travelers count and get the mean. So if you look here, we have our 7-day mean, year to date mean. They're going to be the same until we get to the point where the window has to change down here, right? Once we get to the 8th day, we stop looking at the first day for the 7-day moving average, but we keep looking at it for the year to date, because it's just an expanding window. So I'm just going to show you what that looks like as a plot, so you can visually understand what those are doing. I just have this here so you understand what this snippet of code is doing, as you will see it in there. I'm using SVGs for the images, and in order to make the diffs a little easier to look at, I have a piece of hashing logic that handles that, but this is beyond the scope of this. So basically, if I take the exact bit I had before and just call the plot method afterwards, I can get something that looks like this, which we'll cover more in depth in the next section. But you can see the blue line, the really, really jagged one, is the actual traveler count per day. Then we have the orange one is the smoothed value, that's the 7-day moving average. And the green one is year to date. So you can see the effect of that huge drop-off dragging down the mean over time, and that's why it ends up over here. So visually, that's what each of those calculations is doing. And again, some links if you want to learn more about different types of windows, maybe that you need for your calculations. And let's take the final exercise of this section before we move on to visualization. let's go over this one. Okay, so first thing we have, again, importing pandas as PD. We use read CSV to read in the file. For this one, I'm automatically setting the drop-off time as the index when we read it in, and then also doing the parsing it as dates. So this column, the index is already a date when this is read in. And that makes it easier than do the resampling. So maybe that you were struggling on that bit, that by default it will use the index unless you tell it which column to use. So here, when we say resample 1H, 1 hour frequency, and then take the columns that we care about, and then calculate their sum within those resampled bits, and then grab the n largest, n being 5, by tip amount. Okay, so these are the 5 hours that had the largest tip totals across the drivers in the data set, which you can see. Any questions on that one?
Can you maybe explain when you would use the ag versus .sum?
So I would only bother, the question was when would you use .ag versus .sum? So I would only use .ag when I can't use .whatever is already there, or if I'm using more than one. So for ag is the only way you can say, the easy way you can say, like, on these columns do these statistics or do these set of 3 things, then ag is going to be the one to use. Yeah. Cool. All right, so we're done with the data wrangling, and now we'll take a little look at data visualization. So this is, obviously we've been looking at a lot of statistics and tabular stuff, and there were definitely things that jumped out at us, but nothing will have quite that effect as a visualization will. Particularly, this is from a project of mine, where you can see that there's infinite number of ways that points can be rearranged and still have the same summary statistics, right? So we cannot just rely on that, despite we spent a significant amount of time on the summary statistics. That has to be used in conjunction with the visuals, okay? And so many people don't really realize that Pandas does have ways to help you create some visuals, and so while we're not going to focus on creating like the most beautiful looking things right now, just getting you started with like the quick and dirty plots that you can get from Pandas is what we're going to focus on. And particularly that's the plot method. So we kind of saw this a little earlier, but now we're going to dive into what it actually entails. So I'm going to read in the TSA traveler throughput that we've been working with, but already cleaned and melted and formatted how we want. And I'm setting the date as the index as a date time. So what you see below is what we're going to be working with for this section. And again, we discussed that before. Okay, so here's what we had towards the end of the last section, where we talked about the rolling and expanding windows, and we visualized what that works. So if we had data that looked like this, we could then call the plot method. And I'm noticing I'm only saying the title of the plot, which ends up right here, the y-axis label, which ends up here, and alpha, which is a transparency factor. Nowhere did I say what columns I wanted to plot, but Pandas just figured it out, right? Likewise, I didn't say what the x-axis should be, and Pandas figured it out. So without you doing anything, by default, when you call plot, you're going to get a line plot. The x values are going to be your index, which is why it was important to set that index as the date right away. And then it's going to create a line for each of your numeric columns. So if we look back here, right, date, the index, that was the x value. This is numeric, so it was plotted. This is categorical, it was ignored. And then these two were numerical, and they were plotted. So we had 3 lines. We completely disregarded this column. Okay? And you'll also notice that this time I didn't suppress the output, so we actually have something that's coming back. This is from Matplotlib, where all the plotting is actually happening under the hood. And what's nice about this is since Pandas returns that object to you, you can continue tweaking the visual after Pandas does the initial legwork. And we'll see some examples of that. Okay, so let's now create a different type of plot. We're going to create a bar plot this time. and it's going to show monthly traveler throughput, and it's going to be done in such a way that we can compare year over year visually. So because we're going to be working with full months of data, we want to make sure we don't have that partial May month in 2021. And so here we're using the slicing to pull out all of 2019 up and through the end of April 2021. So that chops off those 14 days in May of 2021 that wasn't a complete month. And then we're going to create a new column with the assign that is just going to be the month, right? So remember now that the date is in the index. So we can't say x.date because it doesn't exist. So we say x.index, and then because it's a date time index, it has a month, we can just pull that out. Then we create our pivot table to do the aggregation. So on our index, we have unique values of the month. So here I'm just showing head, so it's only the first 5 months. Unique values of the year will go on the column, so 2019, 2020, 2021. I will also say that here, for this type of plot, which one you put as columns versus which one you put as rows matters, right? We saw that Pandas plots columns. So if you wanted to show a bar for each year, your years have to be columns. They cannot be the month, or instead you'll have a bar for each month, which is not what we want. And so the values that we want are the travelers aggregated with the sum, which is what we've been doing pretty much this whole time we've been working with that. So if we look at that data that results, this is what we have below. So a column for each year, and then the value at each of the month. So these are going to be our bars. So to actually create the bars, we have to do a few things. So first, I'm going to start over here. So we're going to take our data that we just created. We call the plot method again, but now we don't want line plot. So we actually have to tell Pandas what kind of plot we want. And so to do that, it's a kind argument. So we say the kind is bar. Okay, and then Pandas decided that they want to rotate all the x-axis labels when you do that. And it's hard to read when you have to turn your head to the side like that. So by setting rot for rotation to 0, it stops the rotation of the ticks. So if you look at the bottom, January, the month abbreviations are all written as you would read them without having to turn your head. X label, the x-axis label, we're suppressing this, right? So if we looked back here, notice this x-axis label was created and we didn't do anything. That's because it was the name of the index. Okay, we don't want that here. It's obvious that these are months. We don't need to tell everyone that these are months. And then the y-axis label ends up over here. This is the figure size. So this is actually in inches. So kind of just mess around with this to figure out what kind of arrangement you want. And then the title we saw before goes up here. Okay, so that's the base plot. This returns the Matplotlib axes object, which I'm calling AX. Okay, so remember the month was 1, 2, 3, 4, 5. So somehow I've gotten January, February, March, their month abbreviations down there. So to make that happen, I'm importing calendar from the standard library. And I'm also going to import, so we'll start with that, importing calendar, okay? And then we're going to jump to this bit over here. So we take our axes object, and we can tell it that we want to set its x-axis tick labels. So instead of saying 1, 2, 3, 4, 5, 6, whatever, we want it instead to use the month abbreviations. So this is already, like I said, base standard Python library, and so the month abbreviation, we go from 1 to the end. Does anyone want to guess why we have to do this? Instead of just saying month abbreviation, why do we need to key in 1 to the end? Yes, it's zero-based indexing, and there's no month 0, right? So otherwise, this would be 1 too many, and it would get an error. So we do this. This chops off that non-existent bit, and then we're only passing in Jan, Feb, March, whatever. And also the reason we have to use the numbers is because if we use the names, then it ends up getting sorted, and then you have, April, August, and then that makes no sense at all, right? So always go in making the plot numerically and then clean up the labels afterwards. And that way you can preserve things how you want them. Okay, so that takes care of this x-axis there. Then for the y-axis, notice I have m for millions instead of having massive numbers there. So to do that, we can import from Matplotlib the ticker module, which has a whole suite of tools that you can use to modify how the ticks, either where they are physically or how they are labeled. So changing the representation. For example, adding dollar signs to things if you wanted to do that. Right? You can't change those in the data because then they're not numeric values anymore, they're strings. So to do the y-axis bit, we take our axes object, we access the y-axis on it, and then we call set major formatter. Okay, major because there's two types of ticks. There's minor ticks and there's major ticks. If you think of a log scale plot, you have those big markers where it's values, powers of 10, right? And then you have the small ticks inside showing within that power of 10 the differences. So the small ticks are the minor ticks, the big ticks are the major ticks. So for the most plots you're doing, you want the major one because that's the one that is actually showing up. So we would take from ticker this eng formatter, which does engineering format. So it figures out the scale of your data and realizes it should be M or B or whatever. And then that takes care of this bit. And then the last thing we have down here is the legend, which looks very different compared to this one, right? Which was in the plot, it had these lines, it had a border. So to customize the legend, we call the legend method, and we can specify that we want no title, because they're years. We want it located in the center, but centered relative to this information. So the coordinate system is 0, 1. So 0, 0 is right here in this corner, and 1, 1 is right here. So 0.5 is halfway across x, and the negative 0.3 is outside the plot. And that's how it's centered around this point. N cols, we want 3 columns instead of them being shown in one single column. And then frame on false, we remove the border from around the legend. And there's still like a ton more things that you could customize in the way the legend shows up. But right now we have a plot where we can see comparatively, right, each month how it fared year over year, visually rather than using the pivot table that we were looking at before. Okay. So let's take a look at how we can plot distributions now. So a different type of plot. For something like this, you might want to create your subplots ahead of time. So we had one plot here in both of these cases. Right? If we want more than one on the same data to compare them, let's say a distribution per year, right? We have 3 years, we would want 3 subplots. So we can make the subplots first and then tell Pandas what we want to plot on each of them. So we now need to import Matplotlib's pyplot module as PLT. And then we can go about actually creating the subplots, which we have up here. So we use the subplots function, and we say we want a layout of 3 rows, 1 column of subplots. They should all share the same x and y axis, so it's very easy to visually line them up. Like, just looking at it right now, you can see the distribution shift over time, right? And then the figure size we talked about before. So this returns a Matplotlib figure object, which we haven't been talking about yet, and then a NumPy array of Matplotlib axes in the same shape that you define here. Okay. So the figure object in Matplotlib, you can think of it as the canvas that has absolutely everything that you've been drawing on for that piece of, for lack of a better word, figure that you're working on, right? So you can have multiple subplots, but you only have one figure for that entire bit. So once we have the subplots, we can actually go about telling Pandas to use them. So I have a for loop here, and I'm zipping together 2 things so that at each iteration I get 1 from each of them. At each iteration I want a unique year, so 2019, 2020, 2021, and I want 1 of the axes. So the first iteration it'll be 2019, and the axes to plot the 2019 values on. The next iteration 2020, and the axis to plot it on. Now, I mentioned this was a NumPy array, right? So here, this is going to work because we have a 1 in one of the dimensions. So you have to be very careful if you decide to do like a 2x2 grid, and you iterate over it this way. Each iteration, you're going to get a row, not 1 by 1. And so in that case, you can flatten it out. But that's a small gotcha to be careful. Okay, so, yes?
Year is year an integer here?
I don't think so.
Okay, so I could do the same.
Oh, it might be, actually.
With categories.
Oh, you can do whatever you want. It could be integers too. It doesn't matter what it is. Yeah, you can,
So for names, I would use names.
yeah. Okay. So, and I just remembered it is an integer because when we read it back in, Pandas, it wasn't from converting the column name. So this time Pandas saw it and was like, oh, these are numbers. Because you can see right here, I have to call it string. Because what I'm doing is I'm filtering down the plot data, and I take the travelers. I'm using lock. I need to give it a string. I can't give it a number. So in order to get the 2019, I need to say 2019, the string. So that happens here. This time they're strings. Yeah. So this is the first iteration is the 2019 data, and we grab the traveler count. That's where we're going to plot. To make these plots below here, there's actually two plots in a single plot. So the first thing is the histogram, which you can see in the lighter blue. So we say plot data, the data frame, dot plot. We say it's a histogram. Don't put the legend on. Use density, and that's just so the KDE and this line up. We have our alpha, which was the transparency. The big difference here is we say that the axes, we give it the axes this time. So before what was happening was, since we didn't specify, Pandas was then getting the figure and the axes and plotting it and then returning the axes. This time, we've gotten the figure and the axes. We give Pandas the axes to plot on. And that's why we can then plot on it again. So we say again, this time KDE, axes, passing that in, and they're both added onto the one that we specify. And then we can set information on that. So we're setting the title. So this is 2019 versus 2020 versus 2021. And then the final thing is you often need to handle like slight tweaks after the plot is done. So one of the ways you can do that is you can take the figure and call the tight layout method, and Matplotlib will try to do some optimization to move things around so they're not like overlapping. So like, you know, this title might have been on top of the ticks, for example, if you don't call that.
Is there a way to do log?
For do what?
Logarithm?
Yeah, log scale. Yeah, you just, it's
With X.
on either one, doesn't matter. You can do both. You can do log, you can do log x, log y, whatever. You just set the, I think it's the x scale, y scale, or something is the argument, like in here, comma x scale, or whatever. Yeah.
See what the time KDE is?
Kernel density estimate. It's the curve that you see. This one. Do you see the curve? Yeah. Okay. So let's do an exercise where we're going to make a box plot.
With that KDE, is there a way to get the parameters and function?
Not from Pandas itself, but I think it's SciPy or NumPy. Just find the underlying logic.
Somebody do it.
Yeah, because even if you're like histograms, for example, especially if you want to do like an animation, you need to like calculate the bins once and repeatedly use them, right? So you can use in NumPy, there's a histogram function, and you can tell it the bins or you can tell it the values, and it'll say, okay, here are the values that are in the bins, and here are the bins and where they are, and then that's what's being done under the hood.
Three graphs, the x-axis is only labeled once,
Because they're shared, so the x-axis is only labeled once because they're sharing the same thing.
but the y is two.
The y is what?
It was true for the y as well.
Yeah, but so if you look at, think about how confusing it would be if only one of them had in this arrangement, right? So if,
No, I agree with
yeah,
you. Just from the coding standpoint, though, you got both of them.
yes. So if you added another column, those would not have the y label. It's just that there's nothing across. So if you change this code, right, and instead of saying 3-1, do 1-3, you're going to have the opposite situation. There's multiple x, but there's no y. It's because if there's nothing to the side of it or above it, it's not going to do it.
So it's not that the title from the one below it is covering the label of the.
No, no, no. If you remove share X, then you will have the title again. Yeah. Okay, let's go over this one. So this one, probably the hardest part is not at all the plotting. It's the remembering that you need to reshape the data to get to do what you want to do. Okay, so first I'm just going to do some imports. So I'm going to be using the ticker module from Matplotlib once more. I'm also importing Pandas. And I'm just going to package everything in a function and then call it just for space on the slide. So basically reading in the CSV first. This gives us the data frame. And from there, you can pivot it. So you need to reshape it because in order to make one box plot per year, that means you need each column to have a year. Right? Remember, each of the columns is what gets plot. So by saying pivot columns equals year, we don't have to specify the index, so just reshaping that, and to put the values there, this gives the plot data that we need. We can call plot with kind equals box, not much changing from before. Here I'm setting some labels, and then I'm using the end formatter again. And so if we get that, and we call it, you can now see, because we've pivoted and made one column per year, we get one box plot per year, and we can compare the distributions. Any questions on that one? Okay, so let's take a quick look at Seaborn. So one thing that's particularly nice about Seaborn is the data format that was hard to work with for Matplotlib becomes easy to work with Seaborn. And so it's nice to be aware of both of them in case you might need one or the other. Okay, so we import Seaborn as SNS, and then here I'm going to use the distribution plot, displot. The syntax here is different, but it is using Matplotlib under the hood, so you can, if you get at the underlying object, you can still edit it in a similar way. So we have to specify the data that we want to use, and that's our data frame. We have to tell it the X, so this is what are the distributions of. This is the travelers column. The new thing here is that Seaborn can make the subplots nicely for us by a particular field. So here we're saying use the year column to split up into subplots, okay? And it's called col for column, not because it's a column in the data, but because we're saying make a new subplot column for each distinct value of year, okay? And that's why there's 3 columns. If I said row equals year, I'd get pretty much the same thing, but it'd be a vertical result. And so you notice here we get the histogram and the KDE, because we're saying KDE equals true, and this is just a sizing parameter. So we didn't have to reshape the data at all to do something like this. Another neat thing that Seaborn has are heat maps. So here I'm just going to select all the full months we have in the data again. I'm not going to go over the Pandas logic. We've seen this exact one a few times already. But if you look at the bottom of the data, right, we have from May on, and this year as NAN, because we don't have that data. But for each other value, we have a total sum of travelers going through in that month. So we can turn this into a heat map, which would be easier to understand. So Seaborn has a heat map function. So we're going to pass in our data, and we're just dividing by millions so that we don't have a massive amount of like giant numbers showing up. We select a color map to use. So these are all coming from Matplotlib, so you can pick a different one if you don't like blues. There's this annotation logic here, true, and that's what automatically labels all of these with the value that each box represents. And it uses this format string. So 1 digit of precision floats. So that's why they all have 1 digit after the decimal. And this returns an axes object, which we can then edit. Right, so we saw the trick about using the month abbreviations. We can do it again here to set them along the y-axis. And we can handle the rotation. We can also add the title in after the fact. So very easy to create something like this. This would be much, much harder to do in Matplotlib directly. So Seaborn has a lot of nice things that are, usually they look very nice, and they combine maybe other plot types, but it handles a lot of the filtering or making different subplots based on the one value, but then looking at a different one, like we saw splitting up by year, which is very handy depending on your data. So I just linked to a couple other things that are interesting to be aware of. You can check these out later. And then let's do a short exercise using Seaborn. All right, let's go over this one. So this was just a slight modification on the previous example that I walked through for the heat map. So here we have our imports. Calendar is going to help with the name abbreviations for the months, but also it has for days as well. And then we have importing pandas and Seaborn. So first thing, reading in the CSV. This is the same bit about setting the date as the index and converting it to a date time. Selecting just 2019, and then creating a new column for the day of the week, and also for the month, which will be what we're showing in there. And remember, since it's in the index, we have to grab it from there, and we can't access a non-existent date column. So with that, then we can do the pivot table, and our x's are going to be the day of the week, so the index. And then along the columns, we're going to have the month column, and we're using this time, the aggregation function is going to be the median of the traveler counts. So with the plot data created, then we can call the Seaborn's heat map function. We're going to again divide by, so these are in millions, and we have the same bit about the annotations and also the color map. This returns the Matplotlib axes object. And then here, this will depend on how you chose to do it. I'm going to have on the x-axis the month abbreviations, so I use that here. And then on the y-axis, I'm going to use the day abbreviations. And then setting the title. And if we call that function, you can see here the resulting heat map. So again, we now have the day abbreviations over here, again from the calendar module, and the month abbreviations. Any questions on that? Okay. So we don't have time for the final bit, which is about a little more how you can customize, but the slides will stay public, so you have access to that. That kind of goes over things like adding reference lines, adding annotations with arrows that are pointing to the data automatically, like shaded regions and stuff. And yeah, so if you liked this workshop, hopefully you did. Again, I have this available to give out. And there's also, if you want to dive more into visualization, I have a workshop dedicated just on that. So I would recommend you finish that little bit we jumped over, and then you can review that. It's also publicly available. And so yeah, I hope you enjoyed. You have links to follow my work. The QR code is for a feedback form. You can also click it in the slides, click the star, and it will go there. And that's very helpful for me. So if you could fill that out, I would appreciate it. Thank you.